All right. Morning, everyone. Happy Sunday. Morning, James. How's it going over there?
Pretty good. Ready for another beautiful day.
That's right. Going through the land of Linux. How's everyone doing in chat? Is everyone ready for... Need some more coffee, yeah. Cheers to that. Coffee. Starlight needs coffee. Fancy. I feel like all of us always need more coffee on this Sunday. Saturday, everyone's like, yeah, let's do this. Everyone's energized and ready to go, and they're drinking their coffee. And then Sunday rolls around, they're like, yeah, I'm good. I just need a little bit more juice.
That's right. Got to get the go juice.
Mm-hmm. Oh, nice. Yeah, Karina, the West Coast, getting some light over there. Early morning hours. Samira, welcome. You are a graphic designer. Cool. Well, Germany. Hades, nice. I love Germany. I've been to Germany, I think 3 times now. Yeah, just through like various trips. From Berlin to the Black Forest. Black Forest is nice. You can get lost there as well. Yeah, I really like Germany. James.
Is it that bad?
I can hear them keys. So James actually upgraded his stream today, so I hope everyone enjoys. He's got a nice shiny new mic. He's got some lighting and stuff going on, webcam.
Yeah. I'll try not to give too much keyboard ASMR.
Yeah. I know I was thinking, I'm like, I need to get even like myself, because you can hear it too when I start going crazy, even though like I have some noise canceling, but I almost need like a stream keyboard that doesn't make any noise, like a non-mechanical keyboard is what I was thinking. Like grab one just for the streams, as much as everyone likes the clickety clack.
Try to keep it down. Type quietly.
The mic is good. It's a really good mic. It picks up on all the good stuff. Yeah, we'll find a way to work with that as well. All good. KS can build you a silent keyboard, apparently, though. Wow.
Now, see, when I built this one, I specifically got the extra loud key switches I put in there. I went with like the Cali Chalk browns or reds, I think.
Nice. Yeah. Cool. Alrighty, well, welcome back everyone to SOC 100-1. This is the prepare course. We're going through it again over here on day 4 of our SOC Analyst training, becoming a cybersecurity analyst. And today we're going to be jumping back into the Linux command line. So we're going to be hopping into our course. We have our VM set up, and we're going to bring up the terminal again. And we've got a lot of terminal action to go through today, so I hope everyone's looking forward to this. We're going to take our time. There's some pretty tough, like newcomer concepts that we're going to be going through today. Data streams and redirectors and variables and such. So we're going to take our time, and we purposely saved this kind of content for the Linux command line as opposed to Windows, just because we find it a lot easier to understand learning these concepts working with data streams and such on the Linux terminal versus working with the CMD or PowerShell command prompts. So should be a good time. It's going to be a little confusing at first. I'm not going to lie, but we're going to do our best to ease that knowledge transfer over to everyone. Cool. So everyone ready to get started? Let's do this. Okay, get my stuff set up here. All right, so like I said, we are over in the lab command line file administration, picking up from where we left off yesterday with command flags and relative versus absolute paths. So we're going to move over to here. Lab steps are, of course, always inside the course, and we're going to kind of go through it more instructor paraphrasing in a way and adding some reinforcement to things as we've been doing. So let's go ahead and open up our Linux workstation over here. And we are going to go ahead and pop ourselves open a little terminal. And what we need to do, my shortcuts are not set up for that. There we go. So what we need to do is keep one terminal on the side, and just like we did with Windows, I'm going to go ahead and open up a little text editor for all this, just so we can explain some concepts on the side. I think I'm actually gonna keep this a little bit more expanded. Oh, cool. It's actually got some different themes built in. Didn't even know that. Nice. Okay, let's go and increase the font to 20, I guess. Yeah, cool. Okay. This way we can all kind of keep track of what we're doing and where we're going, moving along all of this. Alrighty. Cool. Okay. So command line file administration. Let's kind of go through some of these commands. Just kind of where we left off yesterday, random little commands and such, right? We left off with being able to run like ls, pwd, ls tac al, kind of going through adding flags, right? List tac al will give us that long listing, kind of seeing it, I'll walk through that again. ls kind of showing us the normal output, and then running through ls tac a shows us all the hidden files, all of them starting with a little dot in front. And then ls tac al actually combining flags. Instead of doing it like this, you can kind of put them together all in one line, right? And yes, ls tac trial. I'm not sure if bro's here. It's not what he likes. He likes ls-lart. So we covered messing around with various commands and running through the man pages, like a man ls command over here, and then sifting through it for information. And one of the things that I think we need to be able to start off with over here is being able to search through these pages. So we covered some flags yesterday, right? Like tac a and such. But if we actually hit / and note how that kind of appeared in the bottom there. So hitting / inside of man pages and CLI readers, like less allows you to search. So if I were to go ahead and type in tac a inside here and hit enter, then it's actually going to show me all of the listings through this. So pretty cool. anything matching up the TAC A itself. And I can go, so you can see in the bottom, it says press H for help. So I can go and hit H, and you've got all of your instructions over here of how to actually search through the man pages as well. Super cool, super nice, right? And this is kind of the thing that I was highlighting with James yesterday, that Linux documentation is actually really good. And the tools to be able to work with everything you need at the command line level from that Unix philosophy just makes things much easier. Like, you don't even need to go on Google, like your documentation's right here. So for example, if we wanted to go forward one line and kind of find all these matching things, we could use different types of operators over here. That's quite advanced. What I want you to be more familiar with is this, being able to search for a pattern, right? Like / pattern, and then using lowercase n and capital N to search. So I'm going to go ahead and throw that inside there. Pretty neat. So now, right, if I hit Q to exit that little search view, then according to this nice documentation over here, if I hit lowercase n, it's going to help me go through the listings, which it is. As I'm hitting N, it's actually matching up all the TAC A's. KS, you're saying, is the stream title updated? Yeah, it should be. Is it not showing? It should be saying SOC Analyst Day 4. Oh, whoops! I put the go live notification is all what I changed. Thank you for calling. Okay, that should be updated now. So when I go live, it shows everyone that we're on day 4, but I forgot to change the title. Thanks, KS. Nice.
It's Groundhog Day.
Yeah, that's why KS is a VIP in chat. First VIP, by the way. That little diamond next to his name. First VIP, helping us out. So, thank you. Cool. So yes, we can go and search through this, right? Lowercase n to sift back and through, or we can also use the capital N as well too. That's going to allow us to perform some more pattern searches going backwards. So see, if I hit lowercase n, it's going down the listing. If I hold shift and hit N, it's going back up the listing. So super cool, right? You don't even need to use Google. You don't need to go and mess around with any of that. You can just go and hit the man page and perform some search patterns over here. Now I'm actually going to go and reduce that font a little bit, just so that it looks a little bit nicer. Let's do maybe 16, just so it's not so much all at once. Still looks good. Let me know if everyone can still see the screen well enough with the font. Cool. So that is how we find those different types of flags that we want to work with. And we can also go and use a lovely website called Explain Shell, which I think we highlighted a little bit yesterday. But if I were to go inside here and type in ls-tac-al, this actually pulls the same information from the man pages. See, it's exact same, but it does some pattern matching to provide you just a quick reference of what the command is actually doing. So a nice GUI-based way, web app-based way to do it. But I definitely encourage you to also get familiar with the man pages themselves so that you can read through them and you're not limited. You can actually find some more flags as well, but they're both great options, good use cases both ways. Cool. So the next thing that we want to do on this command line file administration lab is we want to start messing around with files themselves. So one command that we want to be able to do is use the touch command. And now touch is actually a way to update file timestamps. But when you actually use touch on a empty file, so if I were to do something like touch test file.txt, actually I should show you an ls first that it's not actually there, so we don't see the file over here, right? And if we run an ls-tac-al, you don't see test file inside of the output either. So if I were to do touch test file.txt and then run an ls again, just for a simpler view, you can see the file has now appeared. And there's nothing actually inside that file. So if I were to go over to, we'll do from the GUI, and then we're going to stay on the command line after that, just to actually show. So I'm inside of my Ubuntu home folder, and I have testfile.txt over here. And if I open it up, there's actually nothing inside. Okay. So let's go. And what we want to be able to do is actually work with files now. And there's one command we're going to show you after putting text inside, putting data inside. Kind of similar like how we did echo hello darkness. All right, so echo hello darkness. Notice that I have the input, like this is my standard in, which I'm going to drop there now, and we're going to come back to that. This is my standard input. And after I hit enter and I send that signal, I send that command out, it drops the output to the terminal. So this is my input, this is my output. Now, if I were to go just like how we did on the command line, so while I'm talking, I said command, trying to say hello darkness. And I put this inside of testfile.txt. Notice that the output now disappears. So we've redirected the output. We've taken that output and used this little redirector here to put it inside of a file. It has to go somewhere. Now, just as we had it, let's go ahead and open up the home, and we'll show you here first. But now you can see the test file actually contains hello darkness inside of it. And I'm actually going to save this. 1 second. Let's just put this on home. Linux notes, just so that I don't lose that somewhere. So let's stay on the command line to do this. And one tool that we can use to do that would be using the cat command. And if I were to do cat test and hit tab, remember that autocomplete, super important to just continue building that habit. Hit cat testfile.txt and notice that it says hello darkness. So this is a way to actually read the output of a file on the command line itself. And cat is a strange command to get used to at first. If I were to go inside of man cat, if I were to go to cat itself over here, okay, we're almost creating like a furry stream over here with man cats and such. So if I were to put cat, you'd see it says concatenate files and print on the standard output. And just like the man page, it says the same thing too. And concatenate is effectively just doing that. It's reading something. So it's reading a file in this case. That's how we gave it. And then actually here, let me exit that real quick. So just as how we put echo hello darkness and we redirected that into test file, when we do cat test file, we are reading the data, the contents of testfile.txt, and we're redirecting that output somewhere. Now, because we haven't given it any further direction, like if I were to do something like cat testfile.txt and then redirect it somewhere else, it would have to go somewhere else .txt. And see, it would disappear. But if I were to just write cat testfile.txt, it doesn't have anywhere to go, so it sends that output to the terminal. And it kind of just lives there. And we're going to get to these data streams later. But notice that if I were to now read the contents of have to go somewhere else.txt, it contains the same data because I've taken the output from here and shoved it inside of that file, just like I've done it from here into that file. So I hope that kind of painted a more clear picture of cat as a quick glance right away, because I know that's a little confusing when students first see concatenate. First of all, it's a new word, and secondly, you're dealing with input and output. So was that clear? Pause there for a quick second, make sure that everyone's tracking with that. Clear. Good. Good. Yes, clear. Cool. All right. So let's continue. So cat is a command to read the contents of files. or keep it simple, contents of files, and print contents to output, which will land on the terminal unless directed otherwise. Touch is a command to read timestamps, but if no, or sorry, but to update stamps, and if no file is provided, then it will just create a blank file. So we can say like echo hello darkness to testfile.txt, then cat testfile.txt will print hello darkness to the CLI. Cool. Simple little notes as we go along. So let's take a look at how to append. So if I were to go to testfile.txt, just a little bit up over there, if I were to say echo hello darkness is the first line, so I want to say my old friend, put this inside of testfile.txt, then cat testfile.txt, you can see that it actually adds a new line. Pretty cool. So hello darkness, my old friend is now inside there. Now, if I were to go and say echo, let's just say overwrite and put one redirector inside there into testfile.txt, cat it again, you can see the file is now completely overwritten. So just like in CMD and PowerShell, as we've seen, this is a common type of operator where we would have one to completely overwrite the file, and then two of them to append data to the file. Super important. You can very, very easily overwrite files without paying attention to that. And of course, you can put safety practices in front of that to make sure you don't, but something to pay attention to. So that's all well and good, right? But truthfully, that's just for like working with data, sending things back and forth, input, output, quick writes, quick append. But fortunately, for Linux on the command line being so powerful, we can use command line interface-based text editors. Now, if we were to run a command called select editor, you can see right away that some of them are immediately installed over here. So first couple options, I always love how it says, it's like right away to the point. Easiest, they highlight Nano.
Wow,
so
don't pick a side, Ubuntu.
Yeah, I know. So if anyone was trying to say which one is easier or harder, the operating system itself is telling you that Nano is the easier text editor. We're going to use Nano at first, and we'll come back to the arguments of Nano versus Vim later on towards the end of this module. I'm going to say let's go with Nano. It should have been Nano by default, I think, anyways, but just to be sure, we're going to go with this. And we're going to actually specify to use Nano and go inside of testfile.txt. So if I run Nano file that I want to work with, and I hit enter, I'm actually now in a very basic text editor. So I can go and I can delete this entirely and say, hello darkness, my old friend. And notice in the bottom that I have a set of really, really basic ways of working with this file now. This is essentially like Microsoft Word at its most basic level on the command line. Now, what I want to do is I want to save this. So we can go and we can do, you just hit Control X on the bottom. We will see this right over here, and it's going to prompt us, see save modified buffer. So you can hit yes, and it's going to say file name to write, testfile.txt. So just pay attention to those prompts as they come up. And we're going to say yes. And I can say cat testfile.txt. And now I've completely overwritten the file. So pretty easy, right? That's a little bit more familiar for students when you're first working with this. And that's a little bit easier than saying echo and append and overwrite. So when you first get started, Nano is perfectly fine. You can do mass replacing down here. You can cut and paste. There's enough for you to write basic file administration with Nano, and that's what it's for. It is simple. It is lightweight. The prompts are right in front of your face, so you really can't miss them. Anyone should be able to open up Nano and run some text editing on files. Vim is a different story, which we'll get to later. much different story. Cool. See? I'd like to see CMD and PowerShell do this. Sorry, I have to. This is a pro Linux stream over here. Cool. So, straightforward, right? Now, let's say we wanted to clean up some files, and I'll make some notes over here. Nano is a basic text editor which you can use for simple file administration. Nano the last line of chat is blocked by the top of the video on screen. Oh, good call. Okay, wait, let me adjust our cams a little bit over here. Cool. Thanks, Karina. There we go. Cool. Yeah, thanks for that. Alrighty. Let's keep this action going. Also, if someone has a different lo-fi playlist, I'm happy to change it. I think we've been playing this one for like 2 streams straight. Just throwing that out there too for stream quality. All right. Let's move on to removing files now. So if we wanted to get rid of these files that we've created, we can go ahead and do rm test file, and we can actually delete both files at the same time just by putting them together that way, which is pretty sweet. And if I wanted to actually delete 2 files at the same time, I could do cat test file, put this inside of test2 file.txt. I could have also used another command called copy test file .txt and put this to test3 file.txt. Now, if I did this, I have a series of test files over here, right? So if I wanted to do 1 deletion, I could just hit test file, and notice that once I got to test and I started hitting tab, it actually doesn't just autocomplete anymore. It only provides me the remaining options that are available. So very important, make sure that you do develop that habit. Now, if I were to do something like test2 and hit tab, it's going to autocomplete it. And if I wanted to delete, let's just say like this, test2 file, I could, or I could use something called a wildcard, and I can go rm test. Now, if I hit ls, all of the test files, anything after this is now gone. So test and then wildcard asterisk means anything after that would also be deleted as long as it matches up. So under the conditions of, I'll put this on the side here. So rm test would delete anything that matches the pattern of test i.e. test2 file.txt and test3 file.txt would be deleted at the same time. Pretty cool. So that's how we would do removing folders. Now, if I were to do something like directories, a little bit different. If I were to go ahead and say make directory test folder, and now notice that test folder is here in existence. If I wanted to try, yeah, definitely the KS. So if I were to go ahead and do rm test folder, watch what it says. It gets angry. It doesn't like that. So how would I go ahead and do this? Tell me, chat. If I don't know how to use the rm command to delete a folder, what do I need to do next? I have to use the rm command, by the way. But what do I have to do next to figure out what I need to do? Man, I need man. That's right. Okay. Man rm. Man rm. So take a look at this. And more than 3 files or the R are given. Oh, sorry, that's interactive. Let me go down further. Okay. So on the man pages, oh, bro is here. So on the man pages, we can use tac-r, and we can say remove directories and their contents recursively. And remember what I said about searching, right? If I were to go and hit the H key inside of man, you could go and see all of the different types of operators that we could do, right? We can put a pattern. So if we weren't sure, let's go right up to the top in the beginning. Hades. Yeah. Actually, no, not even Tarl. We use Tral just to really throw some anarchy about. So if I were to go inside of the man page and type in / and do some searching, and I wasn't sure, right? I could hit, maybe just to keep the search easy, I could look for direct, right? And I could use that lowercase n to go further down the search on the man page. And here you go. So if I wasn't sure, right? If I were, instead of just like reading an entire man page or Googling, you can get pretty quick on just searching for what you need by hitting that little / and then type in generally what you're looking for. And you can do more advanced search patterns, which we can look into later. But this is going to let me know right away that I need to use tac-r to go ahead and delete that directory. So I can go over here and say test folder. Oh, geez, wow. Test folder. Man r test folder. So go ahead and do that. And notice that if I run a quick little ls over here, test folder is now gone. So there you go. Pretty easy, right? Cool. So we've now shown how to use cat to redirect input-output between files, redirect it to the output of the terminal. We've also looked at using the man page and search operators. We've looked at copying and using the wildcard as well too, to delete mass things instead of individual. So we're starting to get a little bit more optimization and slight automation going at this point instead of just individual commands. And now we can actually chain commands together. So if I were to do something like, let's see, what would we could do something maybe like make directory, test directory. And if I use this little, see this little semicolon over here, if I use one of those semicolons, then I can immediately do another command right after that. And just for intents and purposes, I can do something like hello, darkness. So I'm running around the Linux command line, I'm making directories, I'm spreading hello, darkness everywhere. So in one line, I've actually been able to create a directory and then at the same time, run a command right after that. That's pretty handy if expecting to do multiple commands at once and you want to make like a nice clean line, instead of enter, 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 constantly doing things like that. So that's pretty handy. You can also use, put that inside of our notes over here. Using the and. Okay, so there's also another way to do that, right? If I wanted to do something similar, Karina, one needs to be careful. Are you speaking from experience?
Yeah, don't ever type rm/rf/.
Yeah, you can throw on interactive mode to make sure. So story time. Once upon a time, a young Anthony over here, way back in the MS-DOS days when I was 8 years old, because you could do the same thing over there. I wiped a good portion of my C drive by running a similar command, writing del *** when I was small, because I didn't know what the hell I was doing. I was trying to read some books on trying to delete files. Yeah, that took a long time to fix with my brother freaking out.
That's a quick way to debloat Windows.
Yeah. Yeah, it's true. It's a good portion that you don't need. So, yeah. So we got bro in chat just forcefully deleting everything. We got Karina warning against it, saying, "Hey, you should wait." And yeah. So yes, you can have a lot of fun on the command line. So yes, kind of looking back at the operators over here, if I were to do something like make directory test directory, and if I were to go and echo, or rather and cd into test directory, take a look what'll happen. I'm actually inside of it now. So pretty cool. And the double ampersand operator is important to note because it actually is going to wait for the previous command to complete. And that's something that you want to be able to do to be sure you don't run into some random error or like a race condition where there's timing involved and the computer maybe won't catch up or another process runs first. So if I were to run a command like make a directory and cd into it, then this interpreted line will actually make sure that the make directory command completed properly, and then it also can cd directly into it. So that's a little bit more automation if you're trying to do multiple commands at once instead of spamming individual commands. Nice and handy. Cool. Pretty straightforward, right? Like basics of working with command line file administration. Yeah, same, bro. I actually don't really ever use the semicolon. In fact, I've only really ever used the double ampersand for chaining commands. Yeah. Yeah. Cool. So that's command line file administration lab. Any questions on that? Anyone still tracking? Shouldn't be any confusion, but feel free, drop some questions. We're going to move over to file permissions next. Yeah. Yeah, I love Echo. echo variable contents and such. Cool. Yep. Yeah, that's right, bro. We're actually gonna be using some sleep later. We could all use a little sleep, I think, right, James? A little bit more sleep.
I don't think I've ever had enough sleep.
Yeah, exactly. We're gonna throw some sleep in our bash scripts later, and that'll make us feel like we caught up a little bit. Cypher. Wish it was easy, right? Just sleep 10. Bam, just like wake up 10 hours later. I wish. Okay, bro, it is always. It is always DNS. Always. Always. It's always a DNS issue at the end of the day when it's DNS related. Cool. Okay. So let's take a look at this. Okay, so file permissions is going to be a little strange as well too to get started, but we're going to take our time with this one. It's initially confusing. Like we showed on the GUI yesterday when James was running around, just like going to properties, you can see read, write, execute. That is simple, right? I think everyone understands that. You can just change read, write, execute permissions for things. Now on the command line, you have a little bit more granularity and control how to do that. You can even reference the numerical value of those permissions. So this is why this is going to be a little bit more complex at first as we go, but we're going to walk through it together. So I'm going to go inside here and clean up my file path. Go file permissions. Cool. So let's go up on the root directory, or the root level drive, I should say. And if I run an ls, remember we can see all those fancy directories we saw yesterday, bin folder and such. yeah, bro, that's right. It's so, like the permissions it uses, is anyone familiar with octal? Like we have decimal, we have binary decimal octal. There's different forms of number systems. This is why it's going to get a little strange once we get there. But let's walk through it. Cool. Karina's got a little bit idea. Yeah. So if I were to go inside here and do an ls tac al, right, or ls, or do an ls just for fun, we're gonna do an ls trowel, okay. And notice that if I look at the root directory, we can see some interesting things here. Okay. We see this notation. That's right. That's right, bro. Hades, you have to study it 12 years ago. Yeah, it's good to understand. Okay, so if I'm gonna run, let's just clean this up, okay? Sorry. Yeah, I don't want to get into grep just yet, so we'll come back to that. So if I look at the root directory over here, okay, just this line. This is the important thing that we want to pay attention to right here. So I'm going to actually zoom in. I don't think I needed to do that. That didn't really help at all. Let's go back. I thought that would have just kept the terminal in the same spot, but good old GNOME terminal. Okay, so this is what I wanted to show. Let's paste that over here. And we have a couple things going on. I'm going to actually break this up into what it actually reads like. So the first part is D is equal directory. Now, the first is equal to the owner. Second triple dash is equal to group. Third set of dashes is equal to everyone. So if we look at this type of permission set over here for the root folder, this on disk right over here, it's saying that this is a directory, and we know this by the D. The D is suggesting that it's a directory. And then we have read, write, and execute permissible on this folder by the owner. Now, the owner is the first column over here. So this is the owner of that directory. It's saying that the root user is the owner. And if I were to do ls tac-al on the home directory, you can see that my Ubuntu folder for me as my user, Ubuntu, is the owner of this folder. Now, by default, unless specified otherwise, you're going to notice that the group is also the same username of the user who created that folder. So this is why you see like a whole bunch of root, and then over here there's a difference of Ubuntu. So pay attention to that. Unless otherwise specified or changed, you're going to see that type of notation appear. So we can see that the root group doesn't actually have any further permissions, and everyone else has no permissions either because it's blank. And if we were to look at, how did you touch some file, or rather home Ubuntu, or rather, yeah, home Ubuntu, some file.txt. And if I were to do run list tac-al on home Ubuntu, you're going to notice that some file.txt has a dash in front. And the dash in the front is just going to be specified when it's just a regular file. So there's no notation of what it actually is. So it's interpreted as a file. So we'll go back over here and kind of read through the permissions of root. Again, group, no access. Everyone else, no access. And that is why I can't actually interact with this folder over here. So pretty straightforward, right? That is probably the easiest part to understand. It's just like looking at permissions and seeing read, write, execute, etc. And then D for directories, nothing in the front for files. And we'll get into linked lists and things later, but let's not get into that just yet. Make sense? Yep. Still looking good, right? Okay. Now things are going to start to go a little crazy. So now what do we want to do if we want to change the permissions of a folder or a file on disk? So I'm actually going to go inside of the home directory, go to Ubuntu, and I mean, you know what? I'm going to make a new folder, permission testing. I'm going to cd inside of it as well, just so this is like nice and clean, so I don't have lots of crazy output everywhere. And I'm going to go to touch test.txt. Okay. So by default, if I'm the Ubuntu user and I'm creating things like this, I'm going to see that there are some default permissions, at least by the system, to provide permissions to folders and files that we can configure in a different way later. But this is sort of like the default permission set. Now, what if I wanted everyone, so that third set, like these three positions, to have full access? If I wanted everyone to have read, write, and execute access. So these are actually representative of, they're called bits. They're called file mode bits, actually. And represent permissions. Bits are a binary value. So we're going to do a little bit of binary over here, right? This is where it starts to get a little interesting. So if I had These are 3 bits, okay? And the way that binary works is, we talked a little bit about this in Windows, right? Binary is a value of either 0 or 1. And that comes from the electronic signal through hardware and voltage electricity. Certain electricity levels, if they pass the threshold, will be interpreted by the microcontrollers and the hardware as a value of 1. So I'll show that in maybe like a diagram. Binary 0 and... So it's going to get a little strange, but stay with me, okay? Here you go. Okay. So when voltage is passing through the computer, through the system, through all the hardware, through all the microcontrollers, everything, through the CPU, there's a lot of electronics in place to filter that power level to just go 0, 1, 0, 1, 0, 1, 0, 1. Now, the computer just does that at like light speed. It does it so fast, but it's actually really simple. It is a very simple operation, but done super fast, that provides all the smoke and mirrors that we're seeing inside of our computers. And a binary value can either be, like I showed you, as 0 and 1. Okay. So if I have 1 bit, that's one state of either 0 or 1 equals 1 bit in this case. But I have 3 bits, and this is where binary starts to get a little interesting. So I technically have the ability to be at 000 or 001. And remember, it can only be in the state of 0 or 1. So binary actually counts like this. Now, this is actually representative of certain values. We count this up in the decimal system of 0 equals 1 equals 2, because we're using positions of these bits. Okay. That music stopped playing. I think it did, didn't it? Yeah, it did. The music stopped playing as soon as I got into that, and I was like, oh, it's about to get serious now. I didn't know what was going on. So, all right, let's continue at that. So, lo-fi.exe. Binary bits in this position over here. Okay. Let's just do that for now. Now, the computer can only interpret this in certain ways. Remember, in states, 0 and 1, 0 and 1, 0, 1. So this is actually the numerical representation of changing permissions. This is actually like saying, and remember those bits above. This is actually equal to dash, 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 dash. Now this is equal to dash, 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 x. This is equal to, you see how it's starting to make sense? It's like the weirdest thing always to type out, because in my head I'm thinking of like different things. There's actually at like the basic level of binary, zeros and ones, is how we change the file mode bits, and it's representative to us on the terminal as a decimal, like a numerical value, which is reflective of the permission set itself. So if I were to go, and we have to specify this in such a way, this is just for one column. If I were to say that I wanted everyone to have full permissions, and the owner, let's just say the owner too, I would want a permission set of RWX, read, write, execute, nothing on group and read write execute, which is representative of saying 707. Because remember, read write execute is equal to all file mode bits turned on, which is represented by this decimal value of 7, which gives us full read write execute. So if I were to do chmod, this is a command to change modes or change file mode bits. And I were to do 707 on perm test and then run list-al again, notice how the permissions have changed and reflected exactly what I suggested it to be. You see? There's a reason to understand that flow. The binary port should come with a warning real copy now. I know, right? We're not going to go into like full binary, but I wanted to reference a little bit about why, like, there's a reason we're building all the way up from the hardware layers up into this interactive terminal session where we are directly changing a binary value. But we don't speak binary as humans, which is why we would refer to the decimal value of this 707 to give the permission set of everyone has read write execute, group is at nothing, and everyone is at 7. I'm going to pause there because that's always the hardest part. And G63, thanks for the follow, by the way. Yeah, right. DT. We're gonna get them on the hexadecimal, base 32, base 64. Yep. Some of the newcomers in chat. Does that make sense? Like, looking at it this way, does that provide a deeper level of insight as to why we can even change the file mode permissions to the way that we do? Yeah. Is anyone unclear on that? Yeah, super, super important. Exactly. Yeah. Thanks, bro. Thanks, Hades. Got the Korean thumb. We're good. Cool. Yeah. It's like, just got to kind of stare at it a little bit more. And then you just need to run through some scenarios and some examples of all this to make it make more sense. So let's say I wanted to give permissions of just the owner, right? I want to do then chmod 700 perm test. Cool, right? Let's say I wanted to have full control of the file, but then just give everyone read access. Well, in this case, I want to give it the value of 4. And we know this because 4 is equal to just giving it, execute. Oh, no. Yeah, I want to give him read. So we'll do this. And we're going to go to list-al again. And we can see now we've changed it so that anyone can read our file, but they can't execute it and they can't write to it. Only I can. So now we're getting into permissions. Pretty important. And this is actually a good example of where we can start doing that double ampersand operator as well. If I wanted to go 777, we can actually work all the way. Just to kind of demonstrate this. Perm test, and we'll do list-al perm test. So I'm actually going to chain commands together right there so that things are a little bit easier to see. Cool. And if I were to go to 701 and go to 702, you can see how that value is counting up. Okay, just want to actually demonstrate that. So just to make it really clear, right, this is how we can change permission sets, and those last 3 bits are the everyone group. And you can see how we count up the exact same way, walking through that kind of binary level to a decimal level, representing those bits. But that's why they're called bits, because they are a binary bit of value, and we just reference it as a numerical digit. So this is a good way to look at it and see kind of an action, because you're going to be doing this quite a bit with Linux file administration and changing security permissions around. There's going to be a whole lot of chmodding. But get ready for that as that time comes. Cool. I think the last thing that I wanted to show was... Oh, I think we have 2 things more to show on this side of things. Yeah, we want to take a look at... nice. Hades. I want to go take a look at folder permissions. So let's go ahead and do make directory new permissions. Okay. And I'm going to take a look at this. And you can see right away that this is redirect execute, redirect execute. And then I'm going to go and say touch new permissions, new perm test.txt. Now I'm going to go and look at the contents of this file now. And if you take a look at the new permissions folder, notice that the permissions of the file inside are different. So what if I were to go and try, let's say chmod 777. Let's just give full permissions to new permissions. So, and you can see like Linux is great. Like we've got like color highlighting everything. So redirect execute all along the way. But the file itself doesn't inherit the permissions. That's important to know. So if you are running file permissions on the command line and you're just like, oh, I'm going to secure this, secure that, and you're changing all your folders, well, your files aren't actually going to inherit those permissions as well. So someone tell me, we kind of did this a little bit earlier with removing directories. How do we change the directory permissions so that the files within it also inherit those permissions? So hop around your terminal. You might want to read the man page of chmod. Someone tell me what I need to do. Mini assignment on the fly.
Might have to give him a minute.
Yeah. Give you guys a quick minute. We'll take a break after his lab as well too to let it really soak in. Yeah, bro.
There we go.
Yeah, cool. We got some recursion going on. Yeah. I mean, I like to just say chmod. You can say like chmod. There's different ways. I like chmod just because it's like nice and easy to say. But good job, Kim. Recursion. Yes, we need to throw in some level of recursion. That's how we were able to delete folders before with the attack R, that recursion component. And that's also a strange concept when you first hear that level of recursion. And what it's effectively saying is you're allowed, to say, Bro's comments always give me a little crack up as I go. So recursion is a concept, at least for file administration and folders, to run a command and continue to execute it upon itself. And if that doesn't make sense, because it typically doesn't when someone first hears that, or it's like to reference itself, I think of it this way. If I were to tell you, go clean the dishes, That is a very different concept than go clean the dish. When you hear go clean the dishes, the interpretation of that is to go inside of a sink and you're going to clean dish after dish with inside that sink. That means you're like all of the dishes will be cleaned. Were UKS? Yeah. So think about it like that. As opposed to if I just said go clean dish, well then it wouldn't carry out the execution of what was intended. And that's effectively what recursion is. It's you go to a state and it just keeps referencing and repeating upon itself until it is done. And that's the reason why you have to throw the tacr when you're deleting directories, is because you have to go in. So we're getting a spammer over here. 1 second. Cool. They should be gone. That's such a weird spam. I don't know if anyone saw that. It's like it said screaming "Long live chaos" and it says add bleach to the food. Who knows? Random bots. But anyways, yes, recursion from a file administrative level, like I said, it's like kind of like going cleaning all of your dishes and is referencing upon itself. So when we run rm-tacr, we are telling the rm command to go inside that sink and clean everything out, including the sink itself. Like that's what happens when you clean the dishes, or at least you should be cleaning the sink at the same time. I don't know if everyone does. I don't all the time myself. Who, you try to. Sometimes you just do the dishes and you're done. But cleaning your folders is effectively the same thing. It has to go inside there, clean everything out, and then the folder can disappear. And that's how recursion works from removing directories. If you didn't have the tacr, it's the command wouldn't be able to complete because it's just going to try to clean the directory itself, but the directory could still have things contained. So it'll block it. It'll kill off that command and won't let you do it. And changing permissions is very much the same way. You have to use a recursion to change the permission of the folder and change all the permissions within inside of it as well too. So we're going to go and we're going to run another command over here. And let's just say we want to carry those permissions. And I'm going to actually go to chmod, just 700 on new perm for a moment, just so you can see that, so that it's actually reset back to this. And this is still the permissions of here. So if I were to go to chmod, tacr 777, new permissions. Oh, sorry, 1 second over here. I feel like I am doing, is it capital R? So used to just using lowercase r. Sorry about that. So capital R, new permissions. So we go inside here now, and if I run listtacl on new permissions, you can see that everything has actually changed, including the file itself. Right? And if I run listtacl, here, the permission set has fully changed, like full permissions for everyone on the folder and the files inside of it. Just remember capitals sometimes. Okay, it's not always a lowercase r. But yes, go ahead, and that's how you would actually change your folder permissions. Now, the last thing that I wanted to show before that, and then we'll take a little break, is using characters. So we could also accomplish something quite similar over here, but we don't have to go crazy with the binary system. And let's go inside. Right. We could actually do, let's clean this file out. Let's just give this like, let's give this 700. Actually, let's give it, let's give it 700. Okay, so now we're actually reset back. And if I wanted to go and change maybe like chmod, we could reference individual columns by using the U or G columns over here if we really, really wanted to do this. So I could do something like chmod group plus RWX. Whoops. New perm test. Now, if I were to go and do list hack AL on new perm test, you can see that by referencing the G, like for group, then we could go and update a column itself. So this is probably a little bit easier, but I like to bring that in after I walk through the binary decimal representation so you actually understand why that stuff is happening in the first place. And truthfully, because I think people in general typically refer to the digits themselves, because that's pretty wordy to go ahead and change like chmod U plus RWX, G plus RWX, new perm. Like this is much more complicated and also easier. Like you're easier to make a mistake at this level just by so many characters you're constantly typing. As opposed to like chmod 770 new perm test, which is once you kind of get that inside your memory, it's easier to work with those values as opposed to longer text. I'm sure preferences can change that depending on who you are, but I always like to consider that the more characters, more typing you're introducing, the more combinations, more level of complexity, things can break easier as a result. So I like to kind of try to be as simple as much as possible. But cool. I'll pause there and we'll take a little break. Kim is saying, if the user who changes the folder permissions doesn't have permissions for all the files inside, will it abort or just change? It'll just change what's possible. Yeah, if there's like like an owner inside there, and the owner has full permissions to something inside the file, then they won't be able to change anything further than just what's in the context of their control, fortunately. Cool. I think it's break time, James.
All right, sounds good. Refill the old coffee.
Coffee, leg stretch. And then we're going to move on to groups after this. Bilbo's coming. The Fellowship. Gandalf is coming as well, too, in the next lab. Grab more coffee time. That's right. I'll just leave a couple more notes over here before that. Chmod tech R is required for directory permission changes and everything inside because of recursion. Chmod, you can do like user, yeah. Go with the group, probably easier.
Oh yeah, Network Chuck does drink a lot of coffee, doesn't he?
Does he?
Yeah, I was reading Hades' comment. And he says every time we mention coffee, he thinks of Network Chuck.
I haven't. So I'll be honest. I've heard a lot about Network Chuck, and I've always wanted to go and watch some of his content, but then I always get lost with things. So I need to go. I hear good things about his content.
He's got some good videos. I've seen a couple of them.
That's what I keep hearing too. But I think you're going to find Hades. When you're in tech, you just start to learn to inject coffee into your veins. It just happens over time. Cool. Okay. Break time, everyone. Where is that break text anyways? There it is. There we go. Back in action. Nice. I like that. KS. Coffee. Yeah, I just refilled the cup as well too. Hopefully I win one of these double plays.
I went upstairs and found that my coffee was not brewed, so
oh no.
I got it brewing.
Nice. Okay, next break. You'll fuel up.
Yeah.
Cool. Good stuff. Yeah, so welcome back, everyone. Redemption, thanks for the follow. Looks like that long-live chaos Twitch scam. So whatever that bot was gave us a follow too. So thanks to that bot, even though you're banned. But cool. Hopefully everyone is enjoying the Linux command line. It's just such a, I don't know, it's such like a nicer experience. Even like the terminal itself, right? What else did we do over here? Some file. Have to go somewhere. Yeah, I think that's all we did. Yeah, okay. Cool. All right. So what are we on to next? We are going to go on to group permissions. So let's update that. Cool. This one's a little bit more straightforward. So lab group permissions. Oh, actually, that's right. We have one more lab to do and before that. Creating users and file permissions. Well, we did file permissions. So I think what we can do is talk a little bit about just quickly adding users, and that'll flow right into the group lab as well too. So what we covered, add user, sudo. Yeah, okay. Cool. So kind of tie it all together over here. So what we want to do is we want to add some users now to have group interactions and permissions going on. So we can use a command over here called add user. And in order to do this, we actually have to start using that sudo command that we talked a little bit about yesterday. And we can throw a little what is sudo. You effectively just executing a command as another user. Now, if we wanted to take a look at our sudo level permissions, we can see we can run effectively everything without any password. So this structure over here is important to pay attention to. And we're going to come back to that later inside of this sudoers file, talk a little bit more about that. But what this can effectively mean is I can run like sudo, if I try to run add user, right? See, only root may add a user group to the system. So when you get a permission error like this, we need to elevate our permission right up. So in order to do that, we're going to go ahead and we're going to throw in this sudo add user, and we're going to go and create, who are we going to create over here? We're going to create Bilbo. Now, notice when I'm adding Bilbo to, yes, sudo equals super user do, which is why, you know, you hear people say called sudo as well. They're both the same. We said yesterday, tomato, all good. But sudo add user Bilbo. Now notice that I ran some commands and things just sort of like generated for it. And notice that the user ID and the group ID over here, these are now at 1001, which I think we covered a little bit about like running the ID command, and we're going to look more at permissions soon. But effectively, when users are created in groups outside of the normal system creation, system installation, and initialization stages, after that's all done, we have this 1000 and up kind of ID tier. So I'm just going to choose password's just going to be Bilbo. All good. Not looking for anything fancy. And notice that it's created a home directory for Bilbo inside of the home, and some typically like startup user creation files from the etc folder where we set all the configuration files lived. Now we can hit a blank entry for all of the final remaining user information, full name, room number. That's just for like work administration. You don't need to fill anything out. I'm just going to go and hit yes. And remember when we ran ID command yesterday, that's what I was going to try to refer to when I was talking, was like the Ubuntu user, the original first user in the system for us to interact with, is at ID 1000 across the board. And then you see a lot of these low level IDs, right? Dial out, CD-ROM, floppy, sudo, audio. There's a ton, but those are all under the 1000 tier. And we'll get to this in networking, talking about like top and common ports. And there's also that notion in Linux user ID and group ID creation that your users, like human interaction, is typically going to be above the 1000 level. That's something to kind of pay attention to. Anything lower is typically going to be service accounts just for managing services. You can see it beyond it as well too, but typically you're going to see that within that range. So now we've created Bilbo. Now let's go ahead and add another user to the system, and we're going to create Gandalf. So sudo add user Gandalf. The fellowship is growing. Going to give the password of Gandalf. Yes, 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 yes. All done. Cool. Now we need to go and we have to use a similar command called addgroup. So we have, remember if I run my ID, right, you can see that I'm this is my group ID of Ubuntu and part of the Ubuntu groups. So I need to go and create a new group, and I'm going to say sudo addgroup. Let's write that over here, add user for creating users, and add group for creating groups. Yes, that's right, Bilbo. Gandalf has arrived. It's never late, nor is he early. Add group. Fellowship has begun. Cool. See, we can see that that group ID, that GID, is now 1003. So no regex checking for the password for length. There's that just a flag. We don't have any password policies set up, so there's really nothing preventing you from choosing whatever you want in this system. Later, we may get into that. That's kind of what we talked about yesterday. Is it'd be cool to have a proper like Linux permission security management course or more content around it, like SE Linux and PAM, adding different layers of security to Linux and such. We get into Linux just enough that you learn how to use it, learn how to learn different concepts like scripting, variables, command redirection, command substitution, the important things that are relatable and transferable to Microsoft and CMD and PowerShell and other things. And we want you to be comfortable with Linux as a tool that you can spin up and use to take further and also work with open source tooling and such. So that's kind of like how far we get with the like that Linux administration side. It's deep, but it's not super deep like PAM and SE Linux and getting into like enterprise security administration and server management to that degree, Kim. So by default, long answer, no. There's no password controls inside of this as it is right now. That's my final answer. So cool. So we've added fellowship group to the Linux box over here. Now we need to modify the current user accounts to add them to this group. So we're going to use a command called usermod. So we need to actually use sudo again, everything's sudo over here, sudo usermod, and we're going to use set of flags of tac AG Tac A is to add users to the certain group, and G is to mention the group name itself. And again, you can always go to explain shell or inside the man pages, start developing that. See append and groups. Either one is good, whichever one you're comfortable with. Fourth dev, thanks for the follow. The fourth dev is here. So we're going to go ahead and do usermod, addgroup, fellowship, and we're going to add Bilbo, and we're going to add Gandalf. Cool. So now if we take a look and see like groups Bilbo, we can see that Bilbo is part of groups and fellowship, and also run the groups command on Gandalf. We can see Gandalf and fellowship as well too. Now if I run groups over here, notice that it's just going to pull my groups. So I have to actually specify who the user is that I'm looking for to see what they belong to. Otherwise, it's just going to default to me. Now, there's actually a list where all this stuff lives. If I actually try to cat the contents of cat etc groups, or sorry, group, then notice you're going to see all of the users part. Like Bilbo has like the Bilbo user group, Gandalf has the Gandalf user group, and Ubuntu as well too, right? Like we have our own user group of those IDs. And this, remember again, Linux, everything's a file. Everything's a file, right? So we can always pull this information from wherever we want, and that's living inside the cat etc group file. Now we see the fellowship group over here is 1003. They should really be over 9,000. That's my preference on that group number. So cat etc group will show us that info, and Bilbo and Gandalf are part of the fellowship group this time. So cat etc group to see who is in groups and group IDs gets a couple little commands there to keep handy as we go along. Nice. Let's keep doing this. So now that we've taken a look at some of the group information, we have our systems in place, and we're going to come back to some permission management over here. Let's take a look at two other important files that make sense of all this. And we're actually going to introduce grep. It's time to grep. I know there's a couple Linux users over here that are all about some good grep and egrep and all the goodness that grep brings. So we're going to start introducing a little bit of grep now to make our lives easier, instead of just dumping terminal output all the time, like cat this, cat that, terminal explodes. So if I want to take a look at the etc group, sorry, the etc password file, if I want to take a look inside of etc password, this is a system. Remember, everything Linux is a file, so we can refer to any file we need as a config file or a reference file. And that's essentially what the password file is over here. It includes all the basic information for user accounts, their user IDs, group IDs, and also their home folder, and effectively their shell. So we can see if I run cat etc password over here, and I'm going to introduce that grep command now because this is a lot to look at. If I do cat etc password, remember we were piping things back in CMD and PowerShell. That pipe operator, remember, is taking the output effectively in this case, and we're going to bring that input over to another command, which I want to now grep, and grep is a search tool. Super handy. You're going to be using grep all the time. And I'm going to search the pattern for Bilbo. So instead of running cat etc password, which just bloats my whole terminal, right? Like everything's dumped over there. I can now pipe that output over, run some grep through the output. And notice that you're going to start saying this as you start going through Linux more and on the command line. You're just going to start using commands as like verbs. Like I am grepping, cat this, grep that, cut that, awk this, said that. Like you're just going to start using that the more as you go, which is perfectly normal. So instead of me catting this output, right, instead of catting all of this output of etc password to the terminal, I can throw in a pipe operator, and then I can grep through that with grep, and I can grep for just Bilbo. And it's going to go line by line. These are all actual line entries. Karina, no, etc password does not contain any encrypted passwords. We're going to take a look at something similar, though, soon. So we can also grep for Gandalf. And this is just a way to quickly verify that that contents does exist. Just like a little sanity check to make sure that we're following along. And that highlight in red is to determine that, yes, it's a proper match. So if I were to do like grep, it's just going to return nothing because this doesn't exist. And we're going to look into advanced grep later. So the cat etc password file, if I look at it, list.al etc password, right? If I look at this, you can see the permissions of the password file. Owned by root, group is root, readable by everyone, so everyone can read this file in the Linux system. There is another file, however, though, etc shadow. So shadow is a different file, and the shadow file is actually where we store all the encrypted and hashed passwords related, as well as potential expiration dates as well too. So notice that I, as the Ubuntu user, I'm included in everyone, and I'm not part of the shadow group. I can't read this file. So what do I need to do? Karina, what do I need to do? How do I read this encrypted contents file if I don't have the permission to? I'm only calling you out because you just asked the last question. Yes. So if I want to do sudo cat etc shadow, now I can read this because I'm running in context of the actual, yes, sudo cat etc password, or rather shadow, you mean, Karina, yeah. So cool. Now I can actually see some information that I see Bilbo over here. And I'm not going to go into full depth until we get to cryptography. We get to this later, like hashing and salting and all that good stuff, encryption, encoding. It's a little bit above us right now, so we're going to come back to this a little bit later. But these are the encrypted passwords of our user accounts for Bilbo and Gandalf. And for where we're at right now, encryption is where you take some text, you run it through a mathematical algorithm that can be completely obfuscated. Like we can't read it anymore. It's completely jumbled up through a mathematical algorithm that can also be reversed through that same algorithm. We'll learn that later on. So the encrypted contents of our passwords are, we cannot read them. Now the system can, and we'll talk more about that later, why. So this shadow password is referenceable by the root account and other needs from other account services if needed. Now, when we talked about the Windows registry, we talked about certain hives. And there's actually, if you remember back from the registry, we didn't get fully deep into it, but Windows actually stores information like this quite similarly in something called the Security Account Manager, SAM. And we'll see later how this type of information can be dumped. This is called credential stealing or credential harvesting. This is something an attacker will try to obtain. They'll try to obtain your shadow file or your SAM file, which is effectively a hive. And I'll talk more about that.
Yeah, that's the Holy Grail file on a machine.
Yes. That is what the attackers want. The Holy Grail. Dangerous times ahead. So, remember that we ran that groups command, right? Groups fellowship. I swear it was, right? Group fellowship? Didn't I just run that before? Oh, no, sorry. Etsy. Anyways, cat Etsy group, right? So when I was looking inside here and I saw cat Etsy group, now we can actually use that grep command. Come back to this, and we can grep through this content, just similarly like how we're using cat Etsy password and grepping for Bilbo, right? We can also start using that grep search feature for cat Etsy group and grep for fellowship, even just fellow itself, and we can see where that actually belongs over there. So now we can start getting some more advanced usage out of our output over here. Cool. So what we want to do is go back to our level of permissions and set up a stage to demonstrate how the group level of permissions work over here. And what I need to do is I need to actually switch over to Bilbo. And in order to do this, I can use the su command, switch user, and I need to throw in a hyphen over here. So su tac Bilbo. Cool. So if I do that, prompts password, and now you can see in this terminal prompt, it's now letting us know. It's now letting us know that we're now the Bilbo user, and I can also run who am I just to be sure in case if I didn't have my PS1 variable. Said it too fast. So this is actually information contained somewhere else in your system as a variable called the PS1 variable. We're going to get to that later, but this is referenceable through that value, and it's constructed to show us that our username at our IP address is always apparent when we're on the command prompt. So now that we switched over to Bilbo, I want to actually go and see where I am on disk. And I just want to make sure I am in the home Bilbo directory. So good. And if you're not, you could always do cd tilde. And that is this value right here. And this is representative. This is a shorthand shortcut for the user's home directory, which is also in a variable that we'll be able to access later. And Karina, yeah, good comment. Yeah, like if it's only accessible by the root account, why would you need to encrypt it? Because, well, there's ways to get to the root account. You can bypass things. So you need another layer of security. So, good stuff. Cool. So let's go inside and let's just demonstrate. If I was here and I went down one level and I'm now in the home directory, and if I did this cd tilde, it's actually going to let me go back to my home directory of home Bilbo. And how do we know that information? If we look inside the password file and grep for Bilbo, you're going to see that Bilbo's home directory is actually home Bilbo. So you see how everything's connected. It's all lined up. Everything references something at some point. Again, Unix philosophy, nice and easy. So what I want to do is I want to go and touch a secret message.txt. I'm going to go inside here and I'm going to say speak friend and enter. inside secret message.txt. So if I look at this file now, this is the contents inside. Take a look at the permissions. This is only accessible by me. So if I were to be switching over to Gandalf, and if Gandalf wanted to be part of the fellowship truly and access this file, well, he wouldn't be able to. Well, sorry, he would be able to read it by everyone. That is true. But we want to be able to set up the secret message to be only accessible by the fellowship. So we need to do a couple things. If I do, remember good old chmod from last lab, and I want to make 770. So I want the owner and the group to have full permissions of secret message. If I go inside here, you can see now that that is the case. So just for the sake of it, I'm going to open up another tab. I'm going to open up a whole new terminal, actually.
Why do we need to use sudo if an attacker can just gain access and use sudo as well? Because we want to limit that. We want to limit who can use sudo as much as possible.
Yeah. So not everyone can use sudo. And you wanna see? If I'm Bilbo and if I try to run sudo, it shows you the command, but if I run sudo tac l, Bilbo may not run sudo. If I take a look at my groups, Bilbo is only part of the fellowship and Bilbo groups, but Ubuntu is a special user for you. And Ubuntu actually has full access to a ton of things and the sudo group itself. Yeah, cool. Looks like I cleared that up, Stephen. Nice. So what I wanted to do was I wanted to go inside here and I want to switch over to Gandalf. And I should, at this point in time, be able to go to back in home and go to Bilbo, right? And I should be able to see this secret message. If I try to actually cat it, I get permission denied. And that's because we just talked about, right? Like I set my chmod, my good old binary permissions. I changed the file mode bits to 770, and that prevents the everyone group, which is Gandalf. From being able to read it. So what do I need to do? There's another command that we need to pull inside here. And we need to be looking at chmod is for permissions, as we learned. And change ownership is for ownership changes. So chown or chown, however you want to call it. I say chmod and I say chown, but that's just me. So you can choose your preference in that. So let's go ahead and let's set up the stage for the fellowship to truly be able to do this and have a secret message between one another. So I need to go back, and if I created this file, remember, I'm Bilbo, I'm the owner. I can control this. I need to use this command of chown. And if I want to be able to do something here, I need to actually change the structure of this to Bilbo, and I separate it with a colon. And I say change it to Bilbo fellowship. Oops, sorry. And I want to change this to secret message. Now, look at that again. Now it's changed versus what it previously was. So this syntax over here, chown, Bilbo fellowship is effectively just changing this value here. Now, it's representative of what Gandalf is seeing, and Gandalf is part of the fellowship group, has the ability of full execution. So I can go and I should be able to read this secret fellowship message, which I can. Cool, right? So I can go ahead and do that. Now, Gandalf, part of the fellowship group, can go and echo melon and append it to secret message. And then Bilbo's now received the secret message between one another. So Gandalf has spoken the elvish friend to Bilbo. So this is how you can create sort of, and this demonstrates the importance of having groups, because if you have group permissions, I don't have to go in between different users and change their permission, change that permission. I can just control it at a group level. And this, the reason why we have groups is because it's easier to put people inside of a group, manage them from there, as opposed to individually, where we could make mistakes. It becomes a lot more error prone. The more interactivity we have, the more combinations, the more times we're touching different things. So pretty cool. We have effectively created the fellowship here inside of our Linux box, and Gandalf and Bilbo are now changing messages to one another. Fun. And we've also introduced a little bit of that grep command. So does that make sense? Is anyone unclear on the group access? I'll pull up the notes. Remember we used add user for creating users. We used add group for creating groups. We used the usermod to throw them inside of different groups by this command over here. And then we can use the groups command to be able to determine who's the members inside of a group. And then we learned how to cat or read the contents of certain files like cat etc password, cat etc password, cat etc shadow, and group. And then we learned a tool like grep. So kind of a packed lab, because it introduced quite a bit at once between all the different file permissions. Most importantly, so yeah, Stephen, you know, as you're saying, it's a lot to take in at once. This is content that you just need to do. So I'm showing you this, I'm walking you through it. Take your notes as you go, but you have to go and you need reps. You need reps on the keyboard. Like your fingers have to hit the keys. You have to make mistakes. This is just time under the belt. It takes practice. And as I like to say, practice makes permanent. It's from my good old past hotel life. And yeah, KS, good call. Good point for that. We do not have a stream next Saturday. And a lot of that, I mean, I'm off. I'm not actually going to be here. I'm taking a little bit of time off. That's why. But it's also a really good time to take a break, because when you look at Windows and Linux, those two modules are packing in a ton of content. And it's a good time for you to just take a pause and start going through it and make sure that you understand everything. Cool. Any questions? Outside of practicing, is anything unclear with that? Cool. Clear. Sweet. We're going to be coming up to proc files really soon, and then services. It's a lot. Today's packed. It's so much to actually like pack in. A lot of Linux concepts, and then we're gonna hand it over to James to finish up with the remaining labs after that. Cool. All right, so we're gonna move over to finding, searching. So now we're moving over to finding and searching. Yeah, Karina, for sure. Chown, what that does. So if I were to go take a look at the permissions of secret message, and if I were to use chown, Bilbo, some group, secret message. Oh yeah, that's right, because it doesn't actually exist. Let's just put it back to Bilbo. And I go inside here. Chown, the structure of it is to put owner group. So it's like saying chown owner group. That's effectively how you need to look at it. Does that make more sense? Good. Cool. You're welcome. Cool. Sweet. Okay. We're going to move over to finding and searching. And we're going to introduce ourselves to the find command. Yeah, Stephen, for sure. I mean, this is for you guys. This is for all of you. There's plenty of advanced content to come. All good. We're taking our time. Because if you get the basics right, everything is much easier. Strong roots, strong leaves. That's how it goes. Cool. All right. So let's go ahead and use a command here called find. And I'm going to make another working directory. Actually, I need to exit out of Bilbo. Go back to Ubuntu. And let's make a directory here of finding. So nothing inside here for now. And I'm going to make a file called passwords.txt. And I'm just going to echo password 123 inside of passwords. So now we have a little bit of data to work with. Okay. It's kind of like our working directory right now. Now I can use a command called find, and the way that it works is find location, options, and pattern, effectively. At a high level, it's kind of how that command works. And I'm going to hit Control C at the end of that to break out of it, but also leave it there in the command line for us to see. Thanks, KS. So we can take a look. I can say like find here, and I can use the option or flag of tac name. And I can say passwords.txt. Oh, sorry, passwords.txt. So now it's letting us know that it's there. And if I were to go backwards one directory, right, and I would say find in the finding directory, tag name, passwords.txt, it'll let us know that's there. So that's a clear match. Pretty straightforward. But we want to be more complex in our abilities. So let's go through this again. And let's say, you know, you're trying to do a quick search and I just typed in like pass. It's not going to come up with anything. And if I were to do find tag name passwords.txt, like for some reason, if you hit capital, it's not going to find anything, even if I did this. So that's not going to work. Now, there are some other options we can work with, like tag iname. This actually makes it insensitive, so case insensitive. So I did something like this. Now, it doesn't matter the case, as long as the overall string matches the characters of like passwords.txt. That's all that actually matters over there. So we can do something like that and we'll be fine. And we can increase the feature richness of our searches by not only making them case insensitive, but we can actually use wildcards like we used before with the rm command. So if I were to do something like this and throw some asterisks around it, this is sort of the structure. This is a pretty neat command. And the structure of it is effectively find dot is like the current location, case insensitive, and I'm going to put here. So this is kind of the way that this works at a high level. So by me using find with case insensitive search and any pattern of pass, regardless of case, I now get a hit, like I get a success. So that's pretty handy. We can also, it's not bad actually. It actually picked up on just about anything inside there. So not bad. So it's kind of just throwing like a whole wildcard search at that point of what we want. Like it doesn't matter. It's just going to retrieve exactly what we're looking for. So one thing I can do is get more specific with these wildcards instead of just wild asterisks that will return anything, because I'm just saying, hey, like return anything within that and make sure that's case insensitive too. I can go inside here and go to iname instead of just like this, right? Because that's effectively what I've done. I can say I want to find extensions of .txt. So that's pretty handy. And this is different than me saying like .exe. You see, like that's not going to work. Now, if I did something just this, right, then it's going to give me whatever. And this is kind of what I did above, saying anything within inside of those wildcards. Like I could put this over here. And if it finds it, then great. If I put a P over here, as long as P is within those two wildcard asterisks, then it's also going to return some results for me. So you can get hyper specific. And it's important to understand using asterisks as a catch-all in your searches, so long as you can like mentally, visually understand what you're trying to find. So if I were to say, return any characters that match anything, separated by a dot, and then as long as it has .txt afterwards, return to me all of the txt files. So if I were a hacker, I would run a command like that. I would run a command kind of saying, return anything to me that has pass inside of it. And that's going to give me passwords.txt. Or I would say, hey, I want to go and try to find all of the .txt files, because that's typically where I'm going to see some type of like someone's quick note, which in this case returns me .txt. So pretty cool. And I can get even more specific. Instead of me just returning like everything at once, I could actually throw in a more complicated string, like tag type F for files. I can also throw tag user, Ubuntu. And all of these options are within like the find itself. They're all here. You can read this. You can find little cheat sheets and shortcuts. But effectively, what I'm trying to demonstrate here is that the find command itself is something that you want to be able to use to be very specific, looking for specific things. And you want to make very granular, filtered search patterns. You don't want something just generalized. Because if I were to go like find in the root, tag iname, pass, like see what's going to happen? It's going to go crazy. And it's just keep going, ton of permission errors. We don't want that. We do not want that at all. We want to be very specific with what we're trying to find, and we also want to craft these search strings instead of just like searching from the root directory. We can also search by permissions too, which is pretty cool. So this is permission set. Like, let's just go ahead and change this to chmod 700 passwords.txt stack al. You can see that's changed. I can do find with anything on a tac perm of 700 if I wanted. It's going to let me know that these are all owner read write execute files. Note that if I put just 400, well, that's not going to return anything. So not ideal. Now, let's say I wanted to we'll find recurse under the location. I believe I have to use. Yeah, you're gonna have to. Yeah, I mean, you don't necessarily need to use recursion because, like, for example, like it starts from where you put a frame of reference. PowerShell is going to be a little different. Each language is going to be a little different. In this case, Bash, like this Bash shell that I'm on right now, if I say to start from this root directory, it's going to start from the root directory. PowerShell is not like that. So you're going to notice these little differences as you go along. It's important to understand how the language behaves. So pretty cool. Now, one thing, I'm going to add on some little complexity over here. We want to throw in this ability to search with grep on top of this. So let's say I wanted to find all of the, let's see. So these are all of like your system log files that we were talking about before in var log. I could do something like find var log. We're going to go iname star.log. Okay. So this is going to give me a list of all of the given log files. So interesting. And we have some permission denied as well too, because we're not sudo. Like we need to be a higher level of permission for what some of these log files are asking for. Now, if I were to do something like find all of these and say like grep error. Rather, let's go sudo find. Notice that that is going to return to us this search pattern here, so if I were to run like find everything, this is only still at the file name level. Now, if I wanted to actually go and search in every single file here, like if I were to do, let's say that I did like cat passwords grep. I know that we have password 123 inside there, right? If I did 123, it's going to search inside of that individual file, just like how we did before, like cat etc password, cat etc group. And if I did something like grep 456, it's not inside there, so it's not actually going to find it. So if I wanted to, right, if I wanted to search all of those logs for password, let's look for pass. We may not actually return anything. Similarly, if I were to find in here tac iname star.txt, so that's our password file, right? And I were to grep for 123, you see it didn't actually return it, but this command did. So if I were to cat passwords.txt and then grep the output of it, I would be able to find it. But just performing a find isn't actually going to help me out here. So what I need to be able to do is throw in another command. And just to be specific, let's just let's just do this first. If I throw in, there's this command called xargs. So man xargs. And what this is actually going to do is dig deeper inside of the standard output that was provided to me. And we're going to get to data streams later to make this click a little bit more. But there's a very big difference between me running find. So this command gives me this output. And if that is my output, that's all I can run grep on. Just this. This command is not the same thing as saying cat. Like you see how this command, cat passwords.txt grep123, tells me that this is inside of the file, because cat, remember, is catting the contents of the file to standard output, standard out, this output right here. And then I can search on that output. But find is not behaving the same way. Find just delivers you a list of file names in this case. So even if we were to grep through it after, we're not actually going to be able to see what's inside. So we can throw this xargs command that allows us to provide arguments, if you will, search patterns to look within inside of the files themselves. So think of it as like a shortcut. By allowing us to throw in more advanced commands like xargs, this is effectively sort of like saying, and this isn't like real per se, but this is like sort of like saying, find this file, then cat passwords.txt, then grep for 123 inside of it. So a little different. Xargs actually allows us to read if this is a file, if this has the ability to be read from, then it will read it just like cat does, and then give us the output of it immediately right away to grep through. And that's why this command works. And this is really important to note when you start running your find commands. And to give some context, if I were to go find sudo find var log tac iname star.txt, so any star.log start.log, and then xargs grep pass. Okay. Here is an example. By me, using some advanced features of like combining find and other commands, I'm able to now, and this is an attacker technique. I am now going to look through all of your log files for all possible entries of where password is inside of each log file. And in this case, I can see like password for Gandalf has been changed. So if I'm looking through the system and I'm trying to collect info and I want like usernames and I want passwords and I want all these things, I want to craft a very advanced find command to sift through it real quick and identify potential information that I can use. And this is also good for you as a defender. If you're trying to find errors, error statements, user issues, application issues, things are failing, things are hanging up, you would want to craft very powerful find commands like this. So Karina's saying to perform the grep on the arguments. Yes. Yes. Well, you can take out on the args. By throwing xargs in there, you're performing grep on what xargs has read, which becomes output of the find itself. So let's look at that again. If I did find iname.txt, I get this file. And if I try to just grep the file, it's not going to find anything. But it would find, if I tried to grep for pass, it would find, say, hey, yes, like your output you gave me, I found passwords in it. Like I found, yes, passwords.txt. But it doesn't have the password entry inside of it. Remember, if I do cat passwords.txt, I see the password inside the file, but it's not giving me that entry. So what I want to do is throw an xargs command to, it's going to read the output, and then I'm going to say xargs grep pass, and now it's going to give me that entry inside the file. So now I've been able to find a stored password on the file system that way. I'm getting like 100 tons of followers. I'm not sure what's going on. Seeing a lot of followers, but I don't know. Did we get rated, or is that like a bot spam happening right now? Do you see that?
Yeah, I see that. The viewer count didn't go up, which is weird.
Yeah, I'm getting hit by like 1 million followers. I'm not actually sure what that means. Let me take a quick look on the Twitch backend. The Twitch backend.
Yeah, it's probably some bots or something.
Bot spam. Yeah. Yeah, I don't know. Just, well, we flew up to 1,100 followers.
See if they can get it over 9,000.
Yeah, I don't even know what that means. It looks like it stopped. Unless we actually got rated. I don't know. But let me take a look at my...
I think when you get rated, you get a message. And also,
should, right?
Yeah, and it dumps the viewers in, so we'd see the viewer count going.
Cool. Well, I don't know. Some kind of random bot spam just happened. I don't know what that means, but we'll find out. So far, so good. Chat seems to be clean too, so just keep an eye on it. But yes, I hope that makes sense. This is pretty advanced, but it's important to see this ahead of time. That when you're working with like find and piping and these commands, like it's very powerful to wield this ability on the command line. And you as a defender and an IT professional would need to use commands like this to troubleshoot, look for errors, find user issues, find software issues. And you would also need to, as an attacker, be able to use this type of technique to look through the system scanning for like stored credentials or like someone left their password in a file. So pretty cool. So I'm going to put those commands inside here. Cool. Kind of pause there, yeah. This is why we save all of this, like the instruction portion on the Linux command line to get this across, because this is a lot easier to work with compared to CMD and PowerShell. But very, very cool. You're starting to see, I hope, the power of working on the command line and being able to do this, like manipulate files and data. Okay. All right. We're going to move on to processes and proc files. Just going to say to James here in the back, I'm just shooting him a quick message over there, just double checking something. So, Kim Fried, is every Linux command able to use other commands? I mean, yeah, so going back to the Unix philosophy of yesterday, remember that every command is meant to be able to build off of one another, like ideally. So the output of one can be used in another way, and then xargs can be used similarly, like this. We can throw in xargs to completely change the functionality of how find is working. Maybe we want to use find to list directory output. Maybe we want to use find to list and search within the contents of those directory listings and files. xargs will be used similarly in other fashion as well too, Kim, depending on the tool before it. Cool. Let's move over to let's do processes and proc files now. Mr. Zen TV. I know who that is. Long live Spartacus, George, and Cicere. Hopefully I got that right. Thanks for the follows. So we're going to take a look now at the processes and proc files lab. And then we're going to take a look at command redirection. And then we'll take a break. And then we got a little bit more to do after that. So we covered a lot of good ground over here. Find xargs, case-insensitive searches, grep patterns. We did a little attack over here trying to search for password entries inside of our log files, which we're able to discover password change entries inside of the auth log. So some cool stuff happened today. Let's keep going. Now is a very important lab to demonstrate proc files. We talked a little bit about it yesterday from the GUI level, looking inside of proc, but now we want to actually show you and use some of the things that we've learned today, finding, grepping, kind of searching through, and really demonstrating how the proc is a virtual file system. So let's kick that off. Okay. So we looking at like processes and task manager similarly before. Let's kind of look at it through the Linux lens now. One command, a lot of like newcomers really love the top command because you run top and it's just like, oh, look at that. Like it looks so nice, right? It's got all this information for you to look at right away. And it's like, oh, I did something cool. So people like top. And top is a real-time task manager, essentially, on the command line. Zeno, you can't. So I tried changing the permissions on proc yesterday. It didn't work. And I was looking up on the side, but that's effectively because it's running within a kernel space. It's a virtual file system. It doesn't actually exist like on disk like these other permissions. So it actually prevents you, even from a root level. And we were saying that like if you were to somehow get to a kernel level and then change the proc permissions, I can't reproduce it, but my bet would be we'd run into like a kernel panic. We'd have like a system crash or something would happen. But just another layer of security built in the operating system. Because you don't want to mess around with proc permissions. Yeah. Okay. So top. We now have a process view. We don't need to look at task manager anymore. Slowly getting rid of our dependency on the GUI. Not necessary. So what can we do inside here? These are all key-based. So if I were to hit H, like I just did right now, H is the help. Like the help ability to see runtime abilities of searching and what we can do inside of the top tool. So if we kind of look at these, there's a couple things we can do. We can look at like load average, task CPU, memory info. We can also locate. So that'd be a Shift L to look for something. So I'm going to go ahead and open up, let's open up calc, I guess. Calculator. So now calculator is running over here. And how to do like a Shift L locate string. Okay, see when I hit Shift L, this locate string changed. And what I'm looking for is like, I guess, calc. I'm not sure. Yeah, gnome calculator. Okay, cool. So Shift L, gnome calc. I swear I just saw it. What was that? Yeah, it's there. Okay. Cool. So we have... Why is that getting so angry? Let's do that again. Shift L, calc. Gnome calc, okay? PID. Okay. Calm down, top. How do you pause this thing again? Pretty sure you can, right? I don't really use top. Can you pause top? That'd be a good question.
Control Z would send it to the background.
Yeah. Yeah, I don't want to background it. Let's do... I'm just going to hit P. Nope. I swear there was a pause ability in top. Let's look it up. Pause top command Linux. Press... Yeah, I don't want it to keep on running.
I think it might be H top. No.
Suspend a terminal. Okay, I guess Control S. That's the easy way. Apparently, yeah. I mean, I don't really, yeah, I'll be honest, I don't really use top. I'm more about PS, which we're going to look at in a moment, but I want to demonstrate this because typically it's an easier thing to do. So let's go to Shift L, calc, and then let's see, where is it? Let's try that again. Calc. Okay, Control S. Suspend. There. Done. Okay, so here's my PID from a top view. Running top. I've now been able to capture the PID of the calculator. And what I wanted to do was actually kill it from the top view. So I'm going to copy that. 558.101. And good question would be actually how to resume it. Unfreezing with Control Q. Okay. Okay. Control Q. Now we're back to normal. So now I'm going to type in K. So now I've brought up the ability to signal a kill. I'm going to paste that in here. 558.101. There we go. Cool. So I guess, top in a way, as I just said, I don't use it. Users typically find us right away. They're like, oh, it looks really cool. I'm sure it's useful for someone that really wants to keep like a dashboard view running at real time to see this information. Like if I were to do like sort by memory usage, hitting Shift M, T by task states, like it's useful. Load average by hitting L. So like in that way, like I get it. It's good in that way. Maybe like process management, I would argue there's a faster way, and that's what we're going to look at next. We're going to look at using other commands to get there. So I'm going to hit Q and actually hop out from top. Clear my screen. And let's use some other commands. We can use something like the PS command. Run side of PS. So this is actually a snapshot. So this is not real time. And I think this is one of, I don't actually know of any other commands that I get angry about this, but this is a command where using the TAC operators, like these flags over here, sorry, not operators, the TAC and these flag options are different from POSIX and Unix. So if I were to go and do like PS aux and PS aux in this case, it's compliant. Like they're going to run the same. But you might be in a system where you actually try to run this and it's not going to run properly. So that's side note if you ever run into that. That's a side note over there. But if I were to do PS aux and kind of see everything, I'm going to open up terminal calculator again. Let that load. And now if I were to do grep calc, arguably way easier, right? Just like immediately be able to see it. And when I run PS aux, what's actually happening here is I am showing A for all users. I'm going to write this one up because it's a little bit more important. User format and X processes not attached to a terminal like calc running over there. So this is a good ability to kind of capture everything at once. Now, remember that grep command, right? Pretty handy over here. If I do grep calc, then I can see gnome calculate over here. And at this point, I could go ahead and do a kill. So I could kill 575. 941. Put up the calculator so you can see that too. So I've killed it. Good to go. So that's nice and easy. I've opened up the calculator once more, and I do psox grep calc, grab the new PID for it, and you can actually do Control-Shift-C. I'm going to start doing that more often now. What did I just do over there? I think I just deleted a bunch of stuff in Notepad. Yeah, I did. Okay. There's like a delay, legit, when I do Control-Shift-C. Interesting. So Control-Shift-C. On the command line. So let's copy that, kill, and that's going to kill off the calculator nice and easy. Now there's something called kill-9. So if I look at man kill, you can see over here, kill actually sends signals. There's interrupt, kill, stop, continue, and you can change the signal of what you're trying to send. So you can actually have a lot more granularity on the command line, because sometimes you don't want to just kill something outright. Maybe you just want to stop it, right? So we can see over here, kill-9, there's actually a song on this, kill-9, where that is effectively the strongest kill. That's like a confirmed kill. That's the signal that overwrites anything that's preventing you from trying to kill it. So you're going to hear kill-9. So if you're trying to kill a process that won't terminate, you can do kill-9. Pretty handy. And that would have just been like kill-9 PID. So let's go add those to our notes. So psox grep process find PID. Cool. Now I'm going to run a couple more commands over here to kind of walk through some things. Control-C that, Control-L, clear the screen. No, it's terminating a process. Karina. It's just called kill. Kill-9. There you go. Make a note of that in your own time. Go ahead and watch Kill-9. It's a whole rap about Linux stuff and Kill-9. So as you start learning more about the stuff, you can have a good time with it. A couple more commands kind of running around processes and proc files. So PS, great command to be able to run through. Grep for what we need, like grep for Ubuntu related processes, grep for calc or get it, like our notepad that's open right now. A lot of cool stuff you can do. We also have some abilities to look at associated information, like we could run the free command, which is going to be showing us our memory consumption. And just like how we had tac h, like list, I did list tac al, it's showing us the consumption and size. If I added an h inside here, it would actually give us the human readable format, like 4 kilobytes. So if I ran free tac h, and this is again that Unix philosophy, the tac h flag is going to give us a human readable format. So we can see like memory consumption 3.8 gigs. Total was what we have. Use 1.9. We don't have much memory left. We can also take a look at like disk usage, running the df command, and again df tac h would give us that human readable format too. So a couple of good commands to know there would be the ps, free, and df commands, which I like to just call disk free. Those are important to know. Cool. Good stuff. Good stuff. Now let's hop over to proc. So proc is the folder we said we can find right at the root level disk directory. So if I were to do like list proc, you're going to see all of this. See all those numbers there. All those numbers these are the PIDs of things running right now. So I'm going to open up a calculator. Okay. We're going to go to ps aux grep calc. This is now 603.252. So if I were to do list proc 603.252, here is the PID running. So the PID running of calc has its own folder inside of the proc folder, which remember, it's like a virtual file system. And this is all the information we can read about the calculator process itself. So if I wanted to maybe read like proc, actually let's do this and go cat proc mem. Sudo. That's weird. Should be able to pull information while it's running. Let's take a look at that. Oh, it's actually file size. Huh. Maybe that's why. So I'm not actually too sure. I wonder why it's not actually letting me post information. Maybe nothing's really like been assigned to it just yet. Let's take a look at some other files then. So I should be able to look at cat proc uptime, for example, which is the uptime of the computer itself right now. So if I were to run uptime, this is letting me know that we've been running for 3 hours, 7 minutes on this workstation. And this is actually pulled from the uptime file itself. So everything effectively inside the proc folder, right? Like proc CPU info. This is where information is living, just as we were kind of showing from the GUI level before. Yeah, good call, maybe, actually. KS in the chat. Let's take a look at that again. Kind of curious why. I wonder if there's something inside there that's actually not letting us be able to read the individual CD 603.252. Should be able to access this stuff. Unless nothing's actually been assigned to it just yet from here. I'm not actually sure. I'm going to have to look that up. Come back on that. But effectively, proc will store all the information related to processes by their PID within inside of the proc folder, inside that like virtual file system. And it'll reference and store information inside here, which I do have permission to. So I'm going to have to look into that, kind of figure out why I can't actually access that, and maybe come back to that a little bit later in the stream. Yeah, when I hand it over to you, James, I'll take a look on the side over here, kind of take a little peek. What's going on with that one?
Sounds good.
Yeah. But cool. So what I wanted to point out more than anything was everything you're seeing. Like if I ran uptime, right? That is coming from me going inside of the proc folder itself. And if I'm catting the uptime file over here that's running, this is recording the information which the uptime command is pulling from. So everything actually lives inside of here, which is pretty handy, I have to say. And we can grep through this just the same, and we can kind of get like an under the hood level view of everything here. Your stat, CPU info, modules that have been loaded, version, you name it. So the things related to your processes running right now are available here for either accessibility through the command line or through different applications itself. Mem info as well too. So we take a look at your mem info. That's effectively what we were looking at before. We're trying to find out some information about like what our computer is using. If I were to run the free command off of this, so like mem total, 394, 130 free. If I ran free right now, free tac h, you can see effectively that like this is the representation of what is being stored right now temporarily in the proc folder, which all of this is going to be wiped afterwards. Like this doesn't live on disk afterwards. This is gone. And this is what I was trying to say. Like I couldn't actually interact with it, changing the permissions because this lives within kernel space. It's just representative of. So like this isn't actually what's on disk is what I'm trying to say. This is living within kernel space. This is dynamically generated just now, living in memory, and we can interact with it through these values, but it's not actually what's being stored. Cap, yeah, it sort of depends, right? Like if you power down, like everything's gone. Log off will wipe off whatever is going to be terminated. Like if I log off, but I don't have my system settings to terminate all my apps, they're still going to live here. But if I log off and I have nothing running, then a bunch of my PIDs are going to disappear as well too. And then there's like shared proc files here that are accessible through just like kind of a variety of programs and apps, like free, df, uptime, everything's referenced from here. So you can always find that information. And if you were trying to create a script, say you wanted to make a script to always like show like how long your computer's been running, you could pull the uptime from here. Like that's fine. Or you could go deep into it, excuse me, and go to uptime, get your own raw values for you to work with. Similarly to if I were to run free tac h, you could create a script that's like, oh, like here's like a constant snapshot of your memory consumption. Or you could go to cat proc mem info. And let's say we wanted to do this, grep tac I mem. And that's kind of advanced. So TAC-I is insensitive. We didn't cover that yet, sorry. So TAC-I is for case-insensitive searches with grep. But if I were to do something like that, then I could have more information raw for me to work with, as opposed to relying off the output of something which could not be always reliable. And that's sort of the beauty of working with proc-related information. Is this is the most raw, most untouched level of information related to processes and the file system and memory and CPU that you could work with. And girl, thanks for having me back. Yes, no weird cuts on the Twitch stream today. Thanks for that call out yesterday. Portugal Bandit, thanks for the follows, by the way, as well. So cool. Let's see. I've got one more to go ahead with over here. Might want to take a quick break, though. Get a cup of tea. Stretch legs. Yeah, let's go ahead and do that. You can take a break, get a cup of tea. Hot tea for the throat. All the talking. And then come back. I think we might go a little bit over today. I hope that's okay with everyone. We're going to go a little bit over today. Not much, just like a little bit, maybe 30-ish, 40 minutes-ish. And then maybe we can do another small stream tomorrow, actually, like a surprise small stream tomorrow, just kind of covering a couple more things, possibly. Cool. So let's go take a little 5-10-ish minute break. We'll get some... James needs that coffee that he brewed like an hour ago. So go nuke that in the microwave, and then we'll be back. Today's a lot to cover. So, all right, let's take a little breather. We'll be back.
Cool.
Oh, no. This isn't a SOC 1 or 2 GRC audit or security control implementation stream. This is SOC Analyst. I had it as Cybersecurity Analyst before, but it was cutting off the title, so it wasn't too enjoyable. But the Kogox, thanks for the follow as well too, just this minute. Anyhow, I'll come back to that after. So command redirection and data streams. Let's update the lab title. That's where we're at right now. So I'm going to go and continue off from over here. And then when James is messing around, I am going to go and figure out more stuff about the proc. Okay, so pull back our terminal. Cool. Alrighty. Let's jump into it. So good old command redirection and data streams. This lab is important for you to be able to understand effectively that while we've been having a lot of fun with different commands, redirectors, operators, piping, a lot of action going on, that there's a reason for all of this to be happening. So we need to be able to break that down, just as we broke down the file permissions before. Remember when we looked at the file permissions and we were looking at the binary representation to decimal to ASCII, like human characters, readable format for us to mess around and throw a little chmod out, change permissions on files and folders, etc. There's a reason why we can do all of this command redirection and input-output stuff happening. And there is effectively 3 main data streams for you to be following and being aware of. We have standard in, standard out, and standard error. Now, call this standard input, standard output, and standard error, or standard in, standard out, standard error. Either one's fine. And these are actually representative on the terminal by the values of 0, 1, and 2. So even these have values as well. Now, to make sense of this as we go along, if I am typing, so I am typing right now, and I am doing things, ls, pwd, who am I, id, etc. When I am typing into the terminal, I am sending, this is my standard input. I am creating input commands like who am I, and the result of the command of standard in this case, after the terminal processes it, interprets it, the computer runs it, and it has a definition of what to do, it gives us output, right? So the output of who am I is Ubuntu. Just like how we had echo hello darkness, and if I do echo hello darkness, this is my standard in that I'm typing in right now. After I execute it, and 2 things have to happen. These 2 other data streams kind of kick in. Standard out, standard error. Standard out, in this case, doesn't have anywhere to go. That's why it goes to the terminal. And that's why when we were typing random characters, and this cannot create any output per se, we saw what we thought was output, but this is actually a different data stream. It is technically output on the terminal, but it appears through different data streams. And that is an important takeaway for us to go through and learn in this lab, because that is how errors happen. That's how certain confidential information is revealed through error codes. This is how redirecting data streams through connections can happen, where you can create backdoors. This is where you can also just use it from a sysadmin point of view to understand more and clean up your output between different operations. So remember when we ran that massive find search for anything that was like star.txt, and we got a ton of errors? Well, we can actually take all those errors and hide them so we don't have to see it. Things like that. And that's what we're going to see. And these data streams allow everything to be happening in the first place. So if I were to do echo hello darkness, and I redirected the standard out, this is what this redirector is actually doing, and I redirected this to a file, some new file.txt. This is why the output doesn't appear in the terminal anymore. That is why, because we are taking that data stream and putting that data stream to a destination, to a location. And this redirector interprets this and says, okay, put that data, put the output of running this command into this command or this output somewhere else. And we can continue to work with it. But when we end it with a file, this shell interprets it as saying store that output inside of a file. And that is why we can run cat and read the input of the file, and then take the input of the file and put it to output inside the terminal. And that's how we can actually read hello darkness on the terminal itself. So something kind of funky happens over here. Because if I were to do some error.txt, and if I were to cat some error.txt, whoops. Here is a clear example of different data streams in action. This command generates this error on the standard error data stream, and this redirector didn't put it inside the file when I ran it, when I try to cat the file. Similarly, if you look at echo hello darkness and its output over here, if I didn't have a redirector, all of a sudden that output goes inside of a file. So what we can safely say is that by default, this redirector as it is will only redirect standard out. That is why an error won't necessarily appear inside of a file when you're redirecting things. So we can sort of like manipulate this in some way. So if I were to go and do this again, and if I were to use the value that represents the standard error stream and say 2, so I'm going to call 2. This is my data stream of 2, standard error, and put this into error.txt. You can see the same thing happen this time. Error didn't actually appear in the terminal. So if I were to cat error.txt, I can now see the error data stream inside of the file. So by using 2, I can specify data streams, tell them where to go. That's interesting. And that's actually why under the hood, these things are happening the way that they are. Does that make sense? Now, what if I were to do let's try to look at this another way. Yeah, let's go echo. Okay, so that's going to work. And if I did cat hello, and if I did this, and I did cat hello.txt, look what happens there. What does that tell you about the data streams? So I'm going to take a guess at it. Even though I didn't have any standard out, I used this operator, which dropped standard error over here, because it doesn't want standard error to go to the file. But the file still got overwritten. Does that make sense? Yeah. Is anyone kind of unclear on this? Well, currently, yeah. So currently, KS, the file is empty, but it wasn't empty before. So that is to say that when I run like some commands here, and if I do a redirect to hello.txt, what will happen now is that standard out will throw an error, or sorry, standard out will be empty, and standard error will tell me something like this: command not found. And hello.txt will be overwritten because we used the redirect operator. Yeah. All right, so yeah, we got a different error. Just whatever, because of all the different brackets and stuff. Oh, yes. Yeah. So if you have a script running, when a script executes, there are still 3 data streams in operation. And if you don't explicitly specify them, they will behave in the way that they just should be behaving by default. And that is a bit of the issue. That is how some of these advanced exploits happen, which we'll take a look at much later on, is by redirecting things around. Normally, if I'm running commands, I want to stuff all my error codes away in somewhere that a user shouldn't be able to see. But if I forget to do something like errors go to error.log, if I don't put that somewhere in my script, then the errors are going to still have to go somewhere. And that's how users can sometimes see information that they shouldn't. That's how hackers are looking for things. That's how you can reveal information that shouldn't be available to people, for example. And then there are more advanced attacks that happen later on, which redirect data back and forth in multiple different ways and can simulate a backdoor, which is something that we'll look at as well much later. So it's what's important to understand at this stage in the game is that there are 3 data streams happening at all exact times, and we can manipulate those data streams just by referencing them by their numbers. In this case, if we wanted to create errors and put them inside of errors.log, then we can go ahead and do cat errors.log and do that. Kind of like if I were to say list tac root, like if I want to go inside here, that's an error, right? Like if that's something that you want to capture somewhere, then I want to go list tac root and I want to put this inside of errors.log. And I want to cat errors.log. And now I can actually record user errors happening on the fly. Now, we could also do some other like weird fancy types of things going on here. We could also redirect multiple streams at the same time if we really wanted to. So we could effectively do something like, let's see. If I were to should give a decent example over here for you guys. Thing to spot. Yeah. Yeah, you're random. It's something that that's a good example, actually, aside from what I'm about to talk about, is that you are a DevOps engineer, and this is useful for you to refresh on. So there's a lot of new students in the chat that have never seen something like this before. We're just hopping on the command line. It's useful when you're in advanced roles as well, too. Like not even just when you've just started like Linux and IT system administration. You're going to have to be working with this again and again. The more command line heavy you get as a defender, as an attacker, as a sysadmin, as an engineer, we're always living in the space of these data streams kind of going back and forth. And it just gets more and more complex, but it's built on the same foundation. So as your newcomers right now, you don't have to worry about getting too convoluted. Just the fact that you have to keep this in mind as you're learning these redirectors, so that when you're writing your scripts and when you're troubleshooting things, you'll be able to remember, like, hey, like, okay, so I'm seeing this error. It makes sense because there's something happening with my data stream. I need to go and troubleshoot it. As opposed to if you didn't know this, you'd be like, what the hell's happening? And that's why we cover it. We cover additional little like nuggets like this. You'll know where to start. You'll know where to troubleshoot and where to begin. Cool. Let's take a look here on this side. How much more do we have of the data stream redirection to cover? I think that's about it. Let's take a look. Oh, Kim, yes. Yeah, the append would function just the same, Karina. The append would just add an extra line, and it wouldn't overwrite the file. So it behaves the same way. And if there was standard out, we would get standard out. But if there was standard error would just be dumped somewhere. Now, there are so we've seen this, like that, the ability to redirect standard out to a file. We've all seen the ability to append. We haven't seen the ability to read to standard in, and we haven't seen the ability to read multiple lines. So that one, we'll see as we kind of go, because that one can be a little bit more complex to understand. If you thought the binary was a bit of an issue, yeah. So Zeno, I guess too, if we do, I guess this will answer Kim as well too a little bit more at the same time, if you're wondering about that. If I were to go, if I were to try to redirect standard error into a file like I did and standard output, I would want to use the concept of doing something like this. This takes data streams, both of them at the same time, as opposed to individual ones. So if I wanted to do, let's so hello darkness, my old friend, right? Hello darkness, into hello.txt. So this is going to rewrite the file over here. And if I did ASDF hello.txt, this is going to drop the error over here. And if I cat hello.txt, nothing happened to my file because I've used that append operator. Now, if I did something like echo hello darkness, and I did put 2 inside here and 1, whoops, 2 caret, why am I hitting the wrong one every single time? And 1, there we go, into hello.txt. Then at this point, I have also, because you have to kind of look like what's happening here. This is kind of funky, but I've echoed hello darkness, and I'm saying take standard error and standard out and put it inside of hello.txt. So what's happened here is it's outputted it, and it's also put it inside the file. And this is a stream telling us kind of like what's going on inside the background, which we don't normally see. Right? If I do this, like you don't normally see that information. But by me kind of tossing out what's actually happening here, what's Jerry saying? It's used to send standard error to standard output. Yeah. Yeah. Yeah, you're effectively, you are combining it. And that could be handy. Maybe you want to capture, like, that's actually part of one of the Linux challenges over here for you to be able to do, redirect streams. But maybe you want to capture, like, all of standard out and standard error at the same time and put it somewhere. So you can kind of have all the output to work with. That's a possibility. But, yeah. But I want to cover this concept over here of reading in, because I think this one could be a little bit tricky as well. So if I were to do something like, there's a command called word count, right? So if I were to do WC, what is WC? This is going to print out a word count of what I need. So if I were to do word count tac L, and if I were to go like hello.txt, it's going to tell me that I have two lines. Okay, so I have 2 lines inside of here, just by using like the tac L for line count of word count. So again, explain shell, word count tac L, go inside here. So this can actually print the new lines by using that instead. But it also prints this. You see how it's printing that at the same time? So if I were to use a different redirector of reading in, so taking in a file, it's actually going to do something entirely different. It's going to strip the file name right away. That is a very different output, right? This might actually be useful, because if I'm trying to just read the input of files, but I don't want the file name messing with, like, imagine if I was writing a script and I always needed to account for stripping file name. Maybe I just wanted the line count. Maybe I wanted the word count. Maybe I wanted just the contents of the file. Having the overhead of the file name included by default creates a lot of additional overhead in scripting and ability to manage that data. So having a redirector like this is actually quite useful. There's also the notion of us having to be able to use multiple lines of code, multiple commands inside of a file at the same time. So we can use this notion of reading in with a double operator in this case. And in order to do this, we actually need something called a delineator. And it's typically used with EOF to mark like end of file. And I'll show you an example. If I were to go and touch multi-line.txt, let's do this and say, I'm going to cat this just to show, like, this is an empty file at this point in time. And if I were to use cat to open up the standard out stream, okay, remember when you're catting a file, You're reading the file, but you're dumping standard out to terminal at that point. That's how you can read files. It's not actually read. You're actually taking the input and putting in standard out, which drops to the terminal. So by the same notion, if I were to do something like this and put a marker, I want to open up an output stream. And once I'm done with the output stream, I want to read it into a multi-line text file. Something funky happens here. If I have this new like prompt, it's telling me to I have input open up to me that I can keep putting in like new files, new code, whatever I want. I can put a whole script inside of here if I really wanted. Like who am I, PWD, ID, etc. Like I can like keep going, right? Now what happens is if I put EOF, because this is my delineator right here, this is actually going to terminate this output stream that I've created. Gone. And remember, cat is taking input, so it's reading something, which in this case is reading my constant stream of standard in, and I am writing that has to go somewhere after I'm done, which is this redirector. So all of this should be inside of multi-line text. That's probably going to be really confusing. And aside though, Jay, so what exactly are you asking over there, Jay? So you want to get a result for 2 is greater than 1? Like you just want to... that? I'm not sure what you're asking, sorry. For everyone else, this function right here, like what I just did, is sort of like the culmination of putting all that together, understanding that we have these 3 data streams in place at all given times. Later, you'll see how this can be abused, but it's important to understand this right now. That if I were to do something like echo hello darkness into hi.txt, I'm typing this command. This is standard in, which executes. Output has to go somewhere, which I am taking into hi.txt. And now I can append it to hi.txt. Again, not overwriting, but taking output further. And normally, if I were to do something like ASDF, like here's an error, that is not going to go anywhere. If I were to go error.log, cat error.log, this is not actually going to be recorded inside of it. So if I were to do something like this and take that data stream, I can now change the behavior and functionality of a normal redirector and capture errors at the same time. So that's interesting. And again, putting that all together of these like streams kind of going back and forth, if I were to do word count by lines of hello.txt, this is a normal function, like a normal command I'm running. But if I were to read it into it, this now strips the file name, which allows me to work with just the contents. It's reading the contents of the file and that's it, which can be helpful in scripting. And then ultimately, if I wanted to create and open up my own data stream, so I'm opening up standard out over here to be able to read what I'm typing in, and I'm going to put that to new multi-line file, some text here. And then I'm going to close that off by that delineator. And if I now cat that's the 3 data streams effectively in action at this point in time. Jay, you're saying, wait a second, why is the number of lines 2 over there? So if I cat hello darkness, hello.txt, I have 2 lines. So when I run I just call it word count. When I run word count tac l, then I actually have 2 lines of code inside here. And there's a huge difference if I'm reading data into the line versus running the command on another command. It actually will strip the file name itself for more advanced scripting and usage. I know it's a lot to take when we get over here. So random saying, if you pipe commands together, will it be just standard in plus standard in? Like if you did a cat hello grep? Yeah, so this is effectively, this is why all these commands work the way that they do. So if I did cat etc password, I think I still have the users in the box, right? Grep Bilbo. So if I still did cat etc, if I did this command over here, what's happening is I am catting etc password. So this is my standard in. It takes the standard output of the file, so it reads the file and it dumps it to standard out. So this would give me that output, but instead of taking all this output and dumping it to the terminal, I'm going to redirect it. In this case, I'm not actually going to redirect it. I'm actually going to run another command on it, and I'm going to grep over it as searching for Bilbo, which the final output becomes just this, because the command hasn't actually finished at this point in time until it's fully completed. So standard output is, this is like living in the middle of nowhere until I'm done working with that data stream, which I've finally grepped on, and then the rest of it is null. It's not necessary, it's not needed anymore. So this is why I actually end up with just this. So random, yeah, if I'm piping commands, I'm piping standard in and standard output around, not just standard in. This data stream has to live somewhere. Does that make more sense to you then, Brendan? Does that answer your question? Yeah. This is probably like the most complex thing that you're going to have to do with data streams, at least at this point in time. And casting, yeah, it's like saying 2 + 2 and then add 1, but not getting the result 4 in the CLI. Yeah, it's kind of janky like that. Any further questions with that? I'm gonna pause there for sure though, because this is something that you need to kind of do on, like, go through on your own, run through some redirection. I think a good example, maybe to sort of like, trying to think of something to sort of summarize the standard out and error into one. So Kim Fried saying is splitting the stream the way some keyloggers work. Data streams will be included, yes. sorry. Data streams will be included inside of keyloggers is what I'm trying to say, Kim. Yes. You'll want to actually copy the data stream happening at the same time. So you're going to capture the key events that happen, like standard in, and then as standard out happens, you're actually going to copy it to a file at the same time. That's exactly how a keylogger will work. And that's exactly how you can abuse data streams. Because remember, this has to go somewhere. Like imagine this was information that I needed. This still lives. This standard out still lives in the stream of events happening. So if I were to copy that somewhere and make an advanced keylogger and find out the certain events that happen, yeah, it'd be pretty cool. Random, is it possible to read data streams? Yes. You need to get a little bit deeper than this, though. You working at a bash level, not bad, but you would want to get to maybe C code, C++ as well too. You're going to have to start working with some advanced code to get somewhere between like memory and kernel space as much as possible with the system calls as well. What you can do in Windows as like a high level example, if you don't want to make your own code, is you could use something like procmon, which we're going to learn later. Procmon and other tools capture all that information, and you can effectively read the events that are happening through all the different data streams as events. Troika76, welcome. You're new here. You're wondering what is the common part between cybersecurity and data science. Cybersecurity is a data problem. Data science is a field dedicated to working with data. Getting insights, observations, tweaking, tuning, pruning, optimizing, normalizing, you name it, on data, which can yield cybersecurity solutions. Because cybersecurity is at the end of the day a data problem. So it's a huge crossover. Now, in terms of the roles themselves, if you want to kind of blend both of them, that's going to be much more advanced. But like SOC analysts aren't really writing algorithms and such with data science. You're more so just kind of putting out fires. Yeah. Lot to cover. Just waiting for any other questions around this stuff, and then I think we can take a little break over here. Grep mouse. Yeah, cool. I guess I'll kind of pause over there. I think the last thing related to that would have just been like, what did we do before with the var log? If I did find var log this, right? That actually might be a decent example. So hard to put this into double stream.txt. And maybe I might want to walk through that actually. Let's go ahead and cat double stream now. Yeah, you know what? I think I'll do that, James. Sort of like wrap that all up, and then we'll take a break. Let me ping you on the side though. So much to cover. Okay, so one last thing that I was just going to kind of cover the chat over here is kind of wrapping that all up. So remember how I had like echo hello darkness inside of I'm actually going to just walk kind of stream by stream double stream.txt. So if I cat this now, one last kind of review of it all. The standard out after running this command is going to go inside of double stream based on this operator's default behavior, right? And if I were to do like ASDF inside of error.log, and then I would capture error.log, I'm now capturing the error data stream. Okay. But what happens if I want to really kind of throw them together? That's what I wanted to show over here. If I go back up and let's run this command first. Okay, so I'm going to run find var log as a normal default Ubuntu user, and I'm going to do a case-insensitive search for any .log files. Okay, now if I do this, I am going to get standard out and standard error on the same output at the end, because they have to go somewhere, right? I haven't redirected that command anywhere. And if I do this, right, and I go to double stream.txt, something strange happens there. All of a sudden, I'm only left with standard error because that has nowhere to go. And if I look inside of double stream, I'm left only with valid standard out. You see how the streams have now split? Standard error has nowhere to go. So what I need to do, because remember, after I run this command, I'm left with this output. And kind of going back to random, you know, you're mentioning like standard in, pipe, standard in. Well, if I were, just like how I ran before, cat etsy password grep Bilbo, this is the result of running this command and then filtering on that output for Bilbo. But that output had to live somewhere. And that's effectively why when we run cat double stream, sorry, when we run this command, that's right. When we run this command, standard error is still living somewhere and it doesn't have anywhere to go. So it just dumps to the terminal. So I have to, after this command completes, I need to go and take standard error and still put it somewhere. And that is why, where's my command up there? Yeah. So at the end of it, I have to take the second data stream of standard error and throw that into the standard out data stream so that they all live in one space. So now if I cat double stream, you can see that I've effectively combined two data streams. I have standard out and standard error going to the same place at the same time. This is handy if you need to run commands and capture output and error together so you know what's going on. And this is handy to figure out if you don't know where error is actually going. Did that make sense? I think we're gonna have to actually like break for the day at that point. It's so much to cover. We might have to actually have James talk more tomorrow because I've talked so much about stuff. It's a big day. I apologize. It's a lot. It's a lot to take in today.
A lot of material. I might melt their brain if I went over my section after that.
Yeah, James has even some more advanced stuff to cover, like advanced scripting. We're going to hop inside of Vim for the first time for a lot of users. I need to make sure that you're all clear on how these data streams are operating. That's really what this lab is. It's a heavy lab. Any questions in chat?
Teaching how to exit Vim is 50% of it.
It's true. Yeah, when I first had Vim open years back, I had no idea the hell was going on.
You just got to ask it nicely.
One does not simply exit Vim. Oh man, a lot on the stream today. Yeah, I don't think we need to. I don't think we should layer on more things today.
Super secret bonus stream coming up tomorrow.
Yeah. So would you guys be good to hop on another stream tomorrow? James, what time would be good for you tomorrow?
And the same time's fine with me, just for consistency.
Cool. Yeah, we can hop on again at 10. It'd be good because next weekend there's no stream next weekend. I'm off, and we gave you a lot to chew on. As James is telling you on the side, Anthony, chill out. Chill out. So we can give you another stream tomorrow and break up the content a little bit. Yeah, random, like yeah, honestly, difficult than first starting, Yeah. Hades, what was it that you were teaching someone a week ago? I'd be curious. Oh, how to exit Vim. Oh, that's what you meant. Yeah. Yeah. I think one other thing I was going to show was, I guess might as well, like, bonus. Okay. One last bonus piece of information. You're going to see this around in a lot of code and script is this piece of information. This is a very special place in Linux. This is called dev null. This is the void. This is where data, memory, everything goes to die. This is a special place inside of the Linux file system and operating system that whatever you put here just gets disregarded. It gets discarded. It'll obviously kick around in memory for a little bit until it's reused or removed, but nothing happens to it. So one last thing that I wanted to show on these data stream pointers is that you'll be able to run commands like this and capture just the standard out, because maybe you don't want standard error at all. Maybe you don't want standard error living on the command line like we saw, because that's how confidential information can be disclosed. So there's a special place. If you don't care about the errors and you don't want to record them, Linux has a spot for you. It's called dev null. So if I take the standard error stream and I dump that inside of the dev null directory, or that space, I should call it instead, then standard error doesn't exist. Yeah, it's the data underworld. So
it's the shadow realm.
Shadow realm, upside down. So by me running this command over here, it is going to just take the standard out, which is valid, put it inside of doublestream.txt, and then all of the error is gone. Like it's gone. So when I cat the contents of doublestream, you can see it's just the standard out that was valid for me. It's going to become quite handy for you later on. But that's also a good example of how you can manipulate these data streams for your needs. And yeah, KS, thanks. Yeah, all streams recorded. So we'll have a special guest, James only. Well, I'll be here tomorrow, but a James primarily stream, walking you through the last bit of content over here in the Linux module. So we covered a ton of ground today. Let's wrap it up. We went from the command line file administration. We looked at creating files. We looked at modifying permissions. We looked at the binary representation under the hood of changing file mode bits for permissions. We looked at recursion. We looked at group permissions of putting Bilbo and Gandalf inside of the fellowship and creating permission-based file control. We looked at finding and searching and piping. We looked at grep. We looked at operators and redirectors. We looked at the proc virtual file system. We looked at processes running. We covered a ton. We covered a ton of ground. And again, the reason why we've done this in Linux is because it's easier to work with on the command line in Linux to demonstrate these examples than it is inside of CMD and PowerShell. But everything that we're doing here is translatable to Windows. There's standard in, standard out, and standard error in Windows as well. And there's different ways that you can abuse this stuff. So you will see this over time. This is, again, like how reverse shells happen and backdoors. You can open up data streams and you can get inside there. You can open up just like a random data stream, whether it's like a network connection, whether it's a standard out, etc. And you can do a lot of bad things. Random saying, what's the opinion that sometimes appears at my server? It's not accessible externally. Oh, so that's different forms of risk. So there's risk acceptance, risk mitigation, risk transfership. In this case, or like risk transference, in this case, that would be like risk acceptance. It's a low risk vulnerability, has a really low likelihood, high impact, but the overall severity is low. There's a very limited chance that that would actually occur. So that would be called risk acceptance. Unless you're trying to refer to something else. Cool. Good stuff. Thanks, James, for being with me here today. Even though I had a lot of tangents and rants to go on, different concepts and things.
Yeah, it's good info.
So James is going to lead the show tomorrow on a surprise stream. So thank you, James, for being available for that. And we're going to wrap up the rest of Linux. We're going to go through, what do we have over here? We have services with system control, scheduled tasks with cron tabs, software administration with package managers, advanced text editing with Vim, scripting and variables, and building a security backup tool. So we got a lot of stuff to still go through tomorrow. And then we've covered a good basis of working with operating systems in the terminal. And again, all of this is transferable over to Windows as well, too, just in its own versions of CMD and PowerShell.
It's going to be a good time.
Yeah, pumped. Cool. So thanks, everyone, for hanging out today on Sunday. Thanks for going through all of that. That's the hardest it's going to be for a while until we get to. Actually, no, I'm lying. Tomorrow's also going to be hard.
Say, until we get to tomorrow.
Yeah. Tomorrow's also going to be hard. So thank you everyone for attending. But you've got next weekend. Next weekend is off. You've got time to let it gestate and simmer. And we're around on Discord as well too. So thanks again. We'll see everyone in Discord for the rest of the day today. We'll be kicking around. Look out for the recordings coming up tomorrow. It takes about a day and a half to process them. So thank you again, everyone, for being here. And thanks for all the tons of follows, including the random spam that we got. That was great. We're somehow above 1,200. And thanks again, James, for being here with me. Thank you all for the great questions.
And thanks, everyone.
Have a good rest of the day, guys and gals. Yeah, tomorrow's going to be a good one. Tomorrow's going to be a real good one. Cool. Thanks again, everyone. Have a good one.